Hello everyone and welcome to the Buildathon, where it's hosted by women tech makers Vizag, and today let's see how to build good things together. I'm Malla and I'm the Android facilitator for our city, and I'm a student and developer and an intern. You can always catch me up on my social profiles shown on your screen or on my Google developer profile at g.dev/manasmalla. So without further ado, let's move into today's session, composing with Compose. But before we dive ahead, let's just ask the basic question, why Android when we have different platforms like iOS, Mac and Windows and the web itself? Why do we specifically develop for Android? So Android gives us the opportunity to experiment, imagine and create things that the world has never seen. When a device goes from just working to actually making your life easier, Android is behind it. It's the reason your GPS avoids traffic, your watch can text, and your assistant can answer questions. When was the last time you forgot how to drive to a place and Google Assistant helped you throughout? So it's open to everyone, developers, designers, and device makers. The Android is open source so that it allows complete control over the Android operating system for developers, designers, and device makers. It's powerful, 5G phones to stunning tablets, and we're now even entering into the realm of foldables and larger screens. So it's really powerful. Personal, material you, and accessibility. Android has never been as personal as now as before, with Material You enhancing dynamic nature in the Android operating system with colors that come from your wallpaper directly and you at the center. It's private to its core. You're in control of your data. Another reason why Android is it's technology that's useful for everyone at your house. Be it your grandfather or a small baby, all of them use Android in our life every moment. With that, we have around 3 billion active devices today in different form factors like foldables, tablets, Wear OS, Android TVs, our cars, and Google Homes and stuff. Another reason is you can only experience the foldables only on Android. With new updates and enhancements and support for large screens and foldables with the Android 12L dropout. Better together. You can connect multiple Android devices together and your app can run simultaneously and synchronously on multiple platforms that can help and aid your users. Kotlin, Android's recommended development language for programming and developing your application. Write better Android apps faster with Kotlin. Kotlin is a modern, statically typed programming language used by over 60% of the professional Android developers that help boost productivity, developer satisfaction, and code safety. I was once a Java developer when I started my coding career when I was 8, but soon I felt Kotlin has been the most easiest as it helped me reduce most of the boilerplate code and I could write my code efficiently when shortly. So it's expressive and concise. Kotlin's modern language features allow you to focus on expressing your ideas and write less boilerplate code. Safer code. Kotlin's modern features allow you to focus on expressing your ideas and write less boilerplate code. Interoperable. Kotlin is 100% interoperable with Java, so you need not worry if you are a Java developer who is trying to migrate to Kotlin. You can have as much as Kotlin in your project or as little as possible. Structured concurrency. Kotlin coroutines, streamline asynchronous programming, make common tasks like network calls and database updates simple and performant. Coming up, we have Jetpack Compose, Android's modern toolkit for building native UI. If you are a developer who has worked with views, this is like God's gift to you. We have reduced the amount of lines of code that you would need to code a single view, like list views and adapters. Like if you had to write down a recycler view, you had to create a UI for recycler view in the XML part and then come to Kotlin and then Kotlin or Java, whatever you prefer, and then you had to write an adapter and then you had to write multiple lines of code just to achieve a simple functionality. But Google's got you here. Jetpack Compose simplifies your whole workspace. So it has less code, so that you can do more with less code and avoid entire classes of bugs. So code is simple and easy to maintain. It's intuitive. Just describe your UI and Compose takes care of the rest. As your app state changes, that is whatever the data is present on your screen changes, your UI automatically updates. And for people who are new to the word UI, it means user interface or whatever the user can see on the screen. Accelerate development. Compatible with all your existing code so you can adopt when and wherever you want. If you are already having a project with views, just start migrating your code view by view or even text by text, and it's totally interoperable. You can change a single view or you can change your whole project with Compose, and it's totally interoperable. Iterate fast with live previews and full Android Studio support. It's powerful. Create beautiful apps with direct access to Android's platform APIs and built-in support for material design, dark theme, animations, and more. Imagine the time where we had to write lines of code just to achieve a simple animation, like transitioning between from one screen to another using Hero, or it could be just animating some text in or animating an image. It was so difficult, but Jetpack has it for us because Google does understand how motion is very useful for the user. And all of this is powered by Kotlin. So Jetpack Compose has simplified the UI language from XML to Kotlin so that you can take advantage of all the powerful classes and methods that Kotlin provides. Okay, that's enough of code. Now let's dive into design. And let's introduce and have a deep dive at Google's new design system, Material U, a radical new way to think about design. Embraces emotion and expressiveness, celebrates the tension between design sensibility and personal preference, and doesn't shy away from emotion. With computing continuing to grow, with more screens appearing in more areas of our lives, users are demanding more expressiveness and control over their personal devices. They're seeking experiences that are just more than practical and functional, experiences that also evoke emotion. Designers across Google from hardware, Android, and app teams come together to respond to this challenge, asking themselves, what if form did not just follow function, but also followed feeling? Personal for every style. Generate unique material palettes for everyone derived from a personal signal, a wallpaper that can be applied to their entire experience. With mix of color science and years of investment in disciplines of interaction design and engineering to make it possible to tailor any app, not just Google's, but even our own, to the user's unique material palette in real time. That's Material U, developing a mode for every mood. Alive and adaptive for every screen. Material U uses motion to help understand space, convey brand, and elicit trust. The UI reacts to screen changes, context changes, and input in a way that is consistent but also human. As technology has moved into different aspects of people's lives, apps have been challenged to adapt to new screen sizes, device types, input modalities, and context. Little surprises and playful quirkiness augment basic storytelling, making technology approachable and comfortable. Accessible for every need. Accessibility is core to Google's mission. By sharing control of contrast, size, and line width with a contextually aware system that can customize UIs in more than previously possible, we can tailor a UI for every user. Okay, enough of theory time. Let's now code. So the requirements are a basic computer and an internet connection, Android Studio Chipmunk or later, and it's an optional, but you can go for an Android device and USB cable if you do not want to run it on an emulator. For people who aren't aware of an emulator is just a simulation of a real Android device on your computer. So let's get started. So we'll be first checking out how to build a birthday card message in the console with Kotlin. To understand the basics of Kotlin, so let's see what all concepts we're going to be covering today. Kotlin syntax, how does Kotlin function and what is the format of Kotlin? What are functions? How do we define functions? Print statements, variables. What's the difference between var and val? Because many people get confused there. Loops and comments. So you can try out all of these concepts and you can try out all this code at https://developer.android.com/training Kotlin Playground. So this is a preview of the text that we're going to be generating in the console. First things up, Kotlin syntax. So let's observe how does Kotlin function, or how does it typeface its code. So if you see at the start, we have the word fun, which stands for a function, like it's the short word for function, and then we have some space, which is followed by the name of the function itself. If you observe here, we are following the camel case syntax. So the camel case syntax just means that when you have multiple words in a name, the first word starts with a small letter, whereas the other words start with a capital letter or an uppercase letter. Next, we have our braces or parentheses, which have the word parameter followed by a colon and the type. The parameter is any input that you want to give it. So let's just assume a basic example of a basic machine where you have some input, wherein you give the input to a machine, then the machine processes something, and then it gives you some kind of output. So let's take an example, a specific example of the same itself. So let's say you have a cake making machine where you feed in all the ingredients as the input, and the machine processes it, and out it gives you the output of a cake. So in the context, your function name would be cake maker or cake builder. It's up to you. It's totally personal. And next, in the parentheses, you'll be giving the parameters, or here it's the ingredients. So you'll be giving, say, one flour, and it could be of a type ingredient. You could create a class called ingredient. We'll get to know what a class is very soon, but you could give a class or the type of the thing to be ingredient, so that you know that, okay, flour is a type of an ingredient. Next, egg is also a type of an ingredient. So you'll give in all those things as parameters or input to your function. Next, after the parentheses, we have a colon followed by a return type. So that is the return type or the output type. What would you want? So here in our context, we would want it to return a cake. So the return type would be of a type cake. Next, we have curly braces, and inside the curly braces is where all your code goes in here. So let's just have a basic demo of how do we create functions, or how do functions run, or the syntax of Kotlin itself. So I just forgot to mention that functions are actually blocks of code that you can run without continuously writing the same piece of code. Like, say, in our example which you have seen previously, we don't want to continuously feed the computer data on how to build a cake. We just give it once that, okay, if you need to build a cake, these are the things which you require, and this is what you need to do with each of them, and this is what you're going to finally give me. We define it once. We don't define it multiple times. We don't want to be wasting our life telling the computer the same thing to do, right? We are all very efficient as developers. So you can put multiple blocks of code together so that you can call them from different places without having to rewrite your same code. Those are functions. And just a note here, the Kotlin compiler always runs the code present in the main function. So now for the demo, let's move over to the Kotlin playground. The link is here on the screen, https://developer.android.com/training/Kotlin playground. So let's move over there. Open it in your browser and we'll start the demo. So here we are at developer.android.com/training/Kotlin playground. Here, if you can see, it says try and practice Kotlin, what you have learned so far. Type in your code in the window below and click on the button to run it, the play button over here. So if you see, we already have some default line of code present here, and it's just defining the main function which I just told you about previously, that Kotlin always runs the code which is present inside the main function. So if we compare this snippet of code with the one that we have seen before, it follows the same syntax. Fun, the function always starts with the keyword fun, which stands for function. Then we have the name of the function itself. Here it's a single worded name, main, with the smaller case letter as per the camel case notation. Then we have some parentheses followed by some curly braces, and we have some code that is run every time when you call this main function inside of them. Here you might observe we have some funny line of code that says println. Just don't get shocked and don't get tense that, okay, I don't have a printer, how do I use this function? Println has nothing to do with your printer, and it's not going to print any line of code to your paper or stuff. It's just going to print the whatever text is inside this to the console. You'll just see what is the console and what this function does in more detail in a few minutes. Here we're just trying to understand the Kotlin syntax. So let's just try to create a function on our own so that we get the full clarity on the Kotlin syntax. So as we discussed, any Kotlin function always starts with the keyword fun. So I'm just going to type it in here, and if you just observed it, Kotlin automatically understood that the word which we typed is a keyword and has given it a color to identify it. Next, let's just here create a function that we can use to build a cake. So I'm just going to write a function, make cake. Oops, sorry for the typo. Make cake, and we're going to give in some ingredients as the parameters or the input. So let's say eggs, and currently I'm just going to define it as a type of a number. And I'm just sorry to take you back to your 6th and 7th math class, but let's just recall what are integers. Integers are numbers which can have a negative value, a positive value, or 0. So mostly we would not be having half egg or 3/4 egg, right? So mostly they'll be integers, at least for this scenario. So I'm going to define these eggs as an integer. So we define integers as int in Kotlin. We're going to learn more about variables and what are the different type of variables we have in a few minutes. Next, we're going to be having flour, which is also going to be taking a type of int. So we're going to enter the amount in mg of flour and other ingredients. Okay, so we have created this a function named make cake, which is going to take in 3 parameters: eggs, which is a type of int, flour, which is a type of int, and other is a type of ingredient. Now we're going to be returning a cake. In general, we'll be going to return a cake, I guess, out of this function, because that is the name of the function itself, make cake. So it should generally be a return type of cake, but since we haven't any default class in Kotlin called cake, we cannot use it. We'd have to manually type it in. So I'm just going to quickly create a class for that. Okay, so it's going to return a type of cake. So don't worry if you did not understand what I just did here when I defined this class. We're going to learn it in a future session, but just for now, just understand that a class is nothing but it just hosts different functions. We've just now seen what a functions are hosting different lines of code or blocks of code, to say better, and classes are just going to host variables and functions together. It's like if you take it with a comparative scenario where you have a class at school, and in a class you have a teacher and some students. So teachers are like your function methods that you can use, and the students could be compared to something like variables. Great. Now let's resume our session, where we have a function called make cake, and it's going to have ingredients or inputs as eggs, which is going to take in a type of int, flour, which is going to take in a type of int, and other ingredients is also a type of int. And what we're going to be returning, it's going to be a type of cake. So it's always not necessary that a function should return something, but it makes sense for some functions to return something. Like we don't want to make a cake but not have a cake in return, right? It's so crazy. So that's why we do have a return type in this case. So to tell Kotlin that, okay, this is the thing which I want to return, like you did some crazy calculation in here, you did some plus, minus, and multiplication, division stuff, and finally you want to return something. So how do you return it? It's so simple and intuitive. You must have guessed it already. We just use the keyword return followed by the variable or the value that you wanted to return. So here in this case, I'm just going to return the type cake. I know that we did not do much, but let's just because we do not have any parameters in our cake class, I'm just going to print the thing so that we understand how do functions work and the inputs work. So I'm just going to use the word println. Just trust me, for now it's just going to print this to the console, and even if you don't understand, we're going to cover what are print statements very soon. So I'm just going to say eggs and then followed by $. We're going to learn about what each of this means, so just hold on to me for a few minutes and believe in me. Next, we are going to write one more for the flour, and let's print the flour variable out, and then println other ingredients, and let's print the other ingredients variable there. Okay, so we have a fair function. Let's just review our concepts back. We have a function defined at the start with the fun keyword, followed with a space and the name of the function itself written in camel case. And then we have a parenthesis covering all the different inputs that you want to give into your function. Here we have eggs, which is the name of the variable or the name of the value that you want to take in as your input, followed by a colon, and you tell what is it going to be a type of. Is it going to be a number? Is it going to be some text? Is it going to be a date? Example, so and so. Next, we're going to have another input called flour, which is also going to be a type of a number, and we have another ingredients, all the other type of ingredients, when we're going to take it as a number. Finally, we have a colon to say that okay, this is going to return something. So what is it going to return? It's going to return a type of cake. And with that, we have the parentheses that are going to be hosting all the lines of code that we want to run whenever this function is called up. In that, we just have 4 lines, which is first line is saying, okay, tell me how many eggs did I enter, how much flour did I enter, and what is the number of other ingredients that I entered. Finally, it's just going to return a type of cake. It's just going to empty as an empty cake, but we're going to modify that in future code labs. Now, for us to run this function and test it out, just remove this line of code, or else you can just let it be. We'll just let it be, and then making a birthday cake. So let's just call in a function from here, make cake. If you observed, we had three parameters that we need to provide to Kotlin so that it can map it to the function we have done. So let's say we had 3 eggs and then 500 grams of flour, and say we had 3 more ingredients. So now let's just assume or test ourselves so that we know the code we done was right. So when it's going to run the main function, it's first going to print out this line hello world with the exclamation mark, and then it's going to run this function make cake. We have passed in 3 parameters, so you can just call in functions in Kotlin just by using the name and the inputs inside the parentheses. So I just call in the same. So we have the input parameters 3, 500 and 3. So they're going to be mapping to this variables that we have defined here. So the x variable would be housing a number of 3, the floor variable will be housing a value of 500, the other ingredients variable would be housing a value of 3. And finally, that is going to be returning us a value of cake. We're not going to capture that value here, but I think it's enough for this session. So if you see, we were totally right. Here it has told us print ln hello world. So yes, we do have that in the console. So the console is just a place where you can print statements and get the input or the output from the Android system or the Kotlin code that you have just written. And next, it's called in the function make cake, and it has successfully printed the print lines eggs, followed by the colon and the value which we have passed in as the parameter, and then the floor print statement and the other ingredient statement. So I guess with this we would have a basic understanding of how Kotlin syntax works. I know that you might have gotten a bit confused, but you'll get it sorted out by the end of the session. So next, now that we have just understood how does Kotlin syntax works and what word is for what, let's now move back into our theory time and let's discuss more about print statements and variables. Yeah, so in our previous demo, you have observed that I have written few lines stating print ln or print. So, but usually we use these words for printing out some lines of data onto paper, right? But here it's not the same thing. So here print statements are very useful when you're developing an application or language, as they help you understand where did your application go wrong, or to debug your application in better words if I can put it. So we have 2 types of print statements in Kotlin. One is a print statement and one other is a print ln statement. If you are really good, you might have already guessed it. Print ln stands for print line. So let's just take an example to compare where do we use which in which situation. Let's go for a scenario differentiation. So here if you see, the print ln statement is going to print whatever text we provide inside it. Just as a pre-measure, I'm just going to inform you that whenever you want to inform Kotlin about some text, or you want to assign some text to a variable, you always need to put it either in double quotes or in single quotes. You can either use one of them, but always go for uniformity. You can either go for double quotes or single quotes. So here I'm using single quotes throughout my session. So here the print ln statement is going to print out this text which I have here inside the parentheses, which is welcome to the Buildathon. So if you might have already observed, the print ln is a function which is accepting a type of string or some text. It's going to accept some text, but print ln is still a function, but it just hosts some more lines than the one which we have already written. So that's the power of functions. You need not write everything on your own. We already have some pre-composed functions that you can use in your code. So that's println, where you can print lines of code with a line break. Next is print, which prints lines of code without a line break. So when I print out the line, I am your host for this session, followed by a comma, it's not going to create a new line. It's not going to go to a new line. It's going to continue on the same line when you run the next print statement. So the next line of print statement was Malla, comma, a 12th grade student. So when I run this, it's going to print I am your host for the session, comma, Malla, comma, a 12th grade student. If I used print ln, it's going to print I am your host for this session, comma, on a line, and Malla, comma, a 12th grade student on another line. So that's the difference between print and print ln. You're going to be appreciating the print statements a lot once you start developing your application. Now let's talk about variables. You might have already learned variables when you are in math class, or if you didn't get understand much during your math session, you're going to do it now. So variables are just used to define lines of code or some values that can change at runtime or are constant. For example, you might have a variable like pi, or 3, which is the value 3.14 or 22/7, or you might have the speed of light as a variable, which is 3 into 10 power 8. Like, you don't want to continuously keep on saying 3 into 10 power 8, 3 into 10 power 8 meter per second, 3 into 10 power 8 second. Or if you're a chemist, you might be aware of the value 6.625 into 10 power 34, which is the Heisenberg constant, or 6.023 into 10 power 23, which is just the number of atoms in 1 gram of hydrogen. So all these numbers are very big, and you need not want to repeat these numbers throughout. So you can just give them a name and you can refer to them by the name. The same thing here in Kotlin or computer programming. So we have basically 6 types of primitives, or the core variable values that any variable can take up. The string, int, boolean, double, float, and any. So before we go through each one of them and how each of them differ, let's just go through how we can define a variable in Kotlin. So in Kotlin, a variable can be defined with 2 parameters, or 2 keywords, rather should I say, a var or a val. A var keyword is used to define a variable that can change during runtime. That is, I can reassign a variable. Say at the start, I had a variable, say my name. My name could change when I'm entering the text input. First it could be Manas, later it could be Malla, or it could be anything. I could continuously change my name. So there, that variable is going to be changing. So that's used, that is defined using the var keyword. Whereas say I had another constant, say 3.14, which I want to use in my calculation, or let's take a more easier example, say my date of birth. My date of birth is not going to be changing, right? So I could have a variable saying date of month I was born, and that could always be 18 because I was born 18/08/2004. So some values change, some values don't. So if a value could change, or if you feel that could change, you define it using the var keyword, or else you define it using the val keyword. So let's just go through the syntax of how do you define a variable. So either you use the var keyword or the val keyword followed by the variable name itself, and if you observed it, we are again using the camel case here for variables that can change or are not constant. But for some variables which you would want to later use and which are definitely going to be constant and should be compiled at runtime, for them you always use capital letters followed or separated by an underscore. So here in our first example, we had var variable name, where v is small or lowercase and n is uppercase, followed by an equal to sign, followed by like if you're defining a text, you need to put it in double quotation or single quotations, as I already told you. So here I'm just defining my text Manas inside double quotes. Next we are defining, let's look at the other example where we're defining a constant. So it's val variable name equal to 12. So because it's a number, you need not put it in double quotes or single quotes. You could also define your variable later, but just initialize it, and you tell Kotlin that, okay, hey, somewhere later in my code, I'm just going to be using this variable just until now understand that there's going to be some variable and it's going to be of this type. So you can just say var variable type and have the colon that's going to define, okay, it's this type. You cannot have a val initialization like this because a val cannot be changed and you're not defining your variable here. So val is not accepted in this scenario. So you always have to use var and you're not initializing the value itself in the declaration. You could also go for late initialization using late init var variable name type. So the app is going to wait for you till you give your value. Once you give it, it's going to start using that value later on. So say if you had an input type of, say you ask the user what is his age, you don't know at the starting, right? So you cannot assume some value like he's 18 years old, so I'm going to just give 18 as age. So you have to wait for him to give the input. So that could be an example of a case where you're going to be late initializing your variables. Now let's just discuss quickly about what are all the different primitives or the variable types that you can have. You can create your own variable types using multiple classes and stuff, but we better stick to primitives for this session. So the 6 different primitives are strings, ints, booleans, doubles, floats, and a type of any. So I just like to point out a note here that the strings, ints, booleans, doubles, floats are all types of any or Kotlin.any. So Kotlin takes the base primitive as any and all these others are just classes that are subclassing the type any. So any is the parent of all these other primitives. Now let's just go ahead and observe each of these primitives. The word string literally refers to text. So if you want to store any text inside of Kotlin, you would always use a string. If you would want to use some emojis or a single letter, you could go for a special type in Kotlin that is char, but we could also use them as strings. Next up we have ints. So as I already discussed, ints are just numbers that can range from positive values to negative values including 0, but they cannot take in decimal values or fractional values. Next we have the type of boolean, and boolean is literally the most easiest primitive type that can ever exist on earth. So it's just going to take your basic true or false. So if a statement is true, the boolean value is going to be true. If the statement is false, the boolean value is going to be false. We use booleans a lot when you're coding because whenever you have a condition in Kotlin, it's going to return you a type of boolean. Next we have up the type double. A double is nothing but a number, but it can host decimal values. For example, 3.14. If you had to denote the value 3.14, you do it as a double. So it's the same like integers. It can host negative values, positive values, but it can also host partial values and decimal numbers. Next up we have float. Floats are also actually used to denote decimal numbers, but they have a small cling on here. So you just need to be a bit cautious when you're using doubles and floats. When using floats, we usually define the range to be between 0 and 1. It's like percentages. Floats you can assume or think of it as percentages. So anything that is 100% would map to a value of 1. Anything which is of 0% would map to a value of 0. And if you're going for 130%, 133%, 200%, 250%, the float value would also map to it, like 2.5f and stuff. So to tell Kotlin, okay, here this is a type of percentage value type, then it's going to be a float, and define it using the value followed by a lowercase f. If it's a double, you just use the decimal value itself. We usually use floats when we are trying to for progress indication and stuff like that, or the task completion, because any value of 0 would mean the task did not start at all, and any value of 100 or 1, sorry, my bad, if a value of the float is 1f, then it could be a value that the task is completed, and anywhere in between would be 50%, 30%, and so on and so forth. Next, the any type is parent subparent primitive, as I told, and it houses all these other types. Now let's move on to loops before we try out a demo. Loops are just used to repeat blocks of code for specific times. We have already discussed that functions are available to run multiple lines of code for multiple times. So you might think like, okay, we have already seen that, okay, you can run multiple blocks of code at once using functions. But again, why do we have loops? I don't want to learn something new just for the sake of it. So, but here's the glitch where it comes on. Functions allow you to run multiple lines of code, but even to run a function multiple times, you need to continuously list out the function itself. And I guess don't want to do that. You don't want to write, suppose say you want to print out the letters A to Z, but you don't want to continuously say you had a list of all the letters and you had to go and print out each of them. You don't want to write, okay, take one variable I and I set that to 0, and then what I start is doing is I print out the first letter, then I increase the value of I so that I get my next letter, so on and so forth. I don't think you would want to write that 26 times. It's so cumbersome. So instead of that, what we can do, we can take advantage of these loops. So here we have two types of loops basically in Kotlin. We have many more, but I'm just going to be covering the most useful two. One is the repeat code, another one is a for loop. So in repeat, it's just very simple. You just use the keyword repeat followed with parentheses, taking in the input as the number of times you would want to repeat a particular line of code. And inside the parentheses is where the block of code that you want to run for specified times is put together. You could put in a function there, and that makes your life much easier. So for example, say you would want to draw a circle. So you can just say repeat for 360 times because the angle in a circle is 360, and you're just going to put in dots at each place. You can write a function for putting dots, and you can just repeat that 360 and altering the angle each time, so that it's going to do it 360 times without you having to manually write down the function 360 times. That would be really hard, right? Next up, we have a for loop, which is for a bit more complex tasks, where you declare a variable using the things which I've seen on the previous slide. Say var I equal to 0, and then you put in some condition. Okay, I want you to keep on looping through the code which I've written until this condition is satisfied. So say I could have I less than equal to 10. So till my variable is less than equal to 10, I want you to continuously loop over my function. Next is where you define the increment variable. So like you're increasing your variable every time the loop is complete. Like say at the starting of a loop, I had the variable value 0. Once I'm done with my loop, the for loop automatically is going to increase the value by 1, and then it's going to again run the same code till my condition met, which is the value should be less than 10. So it's going to run first time, the second time, the third time, fourth time, fifth time, sixth time, seventh time, eighth time, ninth time, and then finally it's going to reach a condition that the value is equal to 10. So there your loop breaks out, and then the remaining part of the code below the for loop is run. So that's how a for loop is defined. Using the for keyword, and inside the parentheses you declare your variable, the condition, the increment variable. There's one more iteration of the for loop which is much easier in Kotlin now. You could just define a range. We're going to be seeing it how to use it in a few minutes, but you could just define like my initial variable says 0, and then I want to run a code till 10, or I would want to run some code from 0 to 10. I can just say for 0.10 and then write the code which I want to, and then Kotlin is going to take each number from that list and it's going to run the code for that particular variable. You could also write another iteration of for loop where you just have you take out a particular instance of a variable from a list of items. You could also define lists in Kotlin. We'll just see how to do them. You can just take each of the variable from there, and then you can run some specific code on them. So I guess it's most of theory time. So now let's go into a demo session. Okay, I just forgot. Before we go there, we just taken a very basic concept of comments, and with that we'll be done with the theory for this part. The thing is, we have three types of comments. You can either write a single line comment, a multi-line comment, or a nested comment. A single line comment, is just used to denote some information which is not read by the compiler. Like it's code, but it's not read by the compiler, and it just stays there. And usually we use comments to tell the other person who is going to be reading a code that what does the following line of code do. So I could just say I could just put in a comment that we're going to be doing this in this part, we're going to be doing this, the Android is going to be doing this, so and so. Multi-line comments, I used to write multiple lines of comments, or usually we use multi-line comments when you have a particular issue in your application and you're trying to debug it. So you'll just try to comment out the code, you'll do it step by step, and you'll identify, okay, so this code is working, this code is working, and finally when you uncomment out, when you start commenting your whole code and then you start uncommenting part by part, you just test it till where is your code running. The place where your code breaks out when you uncomment it, that is the issue place. So you're just going to be inspecting the place there, and you automatically know, okay, so this is the issue where I have it. Nested comments are usually used to denote to the reader of your code, what is this whole page or your file is going to work out. When you have division of responsibilities in your code, you can use nested comments to tell that, okay, so this page is this page of code is going to be helpful in doing this and stuff. So with that, we are done with the basics of Kotlin, and you're now 100% ready Kotlin developer. Now let's just dive into an example. We're going to be building the cake birthday card console that I just shown you here. So we're going to be building this in the console. Let's see how to do it. Playground where we can test and practice out all of the things we have learned. So let's just clear out all the code we have written previously. And yeah. So let's not just clear up this line so that we can just discuss through it. So we have understood now what print statements do. They just print it to the console. So here if you see, this is a print ln statement which is going to take in the text hello world with an exclamation. It's going to print it to the console. So let's just clear out the console and print it again, and as expected it does. So let's now just again revisit our concept of print and print ln. So I'm just going to write another function, print hello, and on the other thing I'm going to write print world. So you might have already guessed it because we were already proficient at print and print ln, but if you see here again, it's going to print out the same thing. But here we could split our print statement into two lines, where there it was a single line. And if let's just change this print into print ln, and let's just observe what's going to happen. As you might have already guessed it, it's going to print it in two separate lines. It's going to create a line break at the when you're done. So you're now proficient at print and print ln. Now let's move to variables. So as I've told you, the 6 primitive types, let's create a variable type of each. So let's say I could create a variable type of name, and that is going to be Malla. That's my name. And let's create a val now for the age, and let's say the age here I'm going to fix it as 17 because my age is 17. So here, as we have already discussed, it's a type of a string or some text, so it should be wrapped under double quotations or single quotations. Next, we have declared the variable val using the keyword val, and its name age, and it's a type of integer because we have no decimals and it's just a number, so it's 17. Next, you can test at how to declare variables, like how to declare boolean. So let's say is today Buildathon, and that I'm sure is going to be true because you're tuning into that right now, so it's always a variable of type true. Next, let's declare another variable. Let's think of where we could use doubles in our daily life. It could be where you have a decimal number. So what's the time now? The time, it's 2:35. So you could define 2:35, where you could, when you split the decimal, you could say that 2 is the hour hand and 35 would be your seconds or minutes. 30 minutes here in this case. So that is one example of time. Let's define another variable of that's going to change, and it's going to be session completed. So we're halfway through, so this is type 0.5f, and that's going to say your session was at 50%. So if you observe, when we are declaring doubles, we don't use the word the letter f, but when you're declaring floats, you always do declare the type f. And whenever you want to understand, or when you have something data coming from somewhere else and you're not defining it, and you would want to know, okay, what type of variable it is, you can just use print name, and it printed the type of the variable minus. And then I could do the same for print age. I could do the same for print is today Buildathon. I could do the same for print time, and I could do the same for print session completed. And if you did guess it out, it would all come on the same line. So just update it to take advantage of the print ln statement. You could also do that using HTML functionality of using the /n, but let's just stick to println for this case. So yep, we do have it. Malla 17 is built in today. It's true. So yes, it's been defined as true. Then time 235 and session completed 0.5. And if you see, Kotlin did take only the new magnitude. It's just going to use this f to indicate that it's a type of float, but when it's going to use the value, it's just going to use the value 0.5. Next, let's go for something a little bit more complex. So now that we have understood all the concepts we need, let's just go and code the birthday card that we have just seen. So if you did observe it, we had a banner at the start with some custom border, and in the center we had the text happy birthday followed by the name. Then we had a birthday cake design having candles made using the comma and a straight line on the next line and a bunch of @ symbols together to make the cake layer. So let's start building it up. First, we know that we have the custom design, and the custom design was just this pattern, which I'm going to be putting it here, var border. It was just this one, this line of text repeated 4 times. So you must have guessed it already. When we are wanting to run something for multiple times, what do we use? We just use the repeat function. So I'm going to do the same thing, but I'm just going to make it my code a bit more precise, and I'm just going to create a new function, say create border. So let's just move in our border variable from there to here, and then what I'm going to do, I'm just going to repeat this line of code for some n number of times. So let's just take that as an parameter. Maybe I would want to change it in the near future, so let's take in it as a parameter times, and it's going to be a type of int because we want a number of how many times. So I'm just going to use that here, times, and then what would we want to do? We just wanted to print the statement, print border. Next, once it's done, we wanted to go to the next line, so I can just use print ln, and it's going to take me to the next line. So we're going to be printing the border, and we don't want it to break the line because the pattern should be on the same line. And then once the pattern is done, we're going to be moving to this other line. So I gave it outside of the repeat command. So we have the border, which is defined using a variable. I'm using that the parameter that we have inputted, that we have accepted, which is times, which is the type of number inside the repeat command, and I'm printing the border for those many times before finally going to a new line. So let's just use that in the main function, create border, and then we need to pass in a number. So let's assume a border of 4. And now run your code, and you should find that the border has appeared finally. Hooray, congrats, you have already finished your first step. Now let's create another function that is going to be typing out the message. So fun create message. So there I wouldn't always create a birthday card for myself, so I would create for someone else. So let's take in the name as a parameter. So I'm going to define name as a parameter of type string. Oops. And inside that, I'm just going to be printing happy birthday. And yep, here you might get a bit strangled upon or might thinking, let's just use the word name. That's what we have done till now. We have used I'm taking this string as a parameter, and I'm using it here. Great. So I'm just going to be using it, and for the sake of spacing and stuff, I'm just going to add in some empty spaces so that we can have the alignment well. So I'm just going to call in the same thing, create message, and here I'm just going to use the word manas, and let's again draw the border to finish it off. And let's run it, and you might have guessed that you would get sorry, I forgot to use the print ln, my bad. So you might have expected that here it would print out the name instead of literally the word name, but Kotlin doesn't understand that you meant the word name inside of a string. So how do you denote to Kotlin that, okay, hey, I don't want you to print the name, I want you to print the value of the variable name? So for that, you could just use the dollar symbol. You might have seen it using me in the previous demo session, but when you use the dollar session, you're telling Kotlin, okay, here, name isn't just some text, it's the variable that I want to print along with this text. So some cases you would have to use a particular variable instance from a class, and there you would have something like you had a user type of the type user, and you had to take the name from that user variable and then put it in here. So that would always ask you to create a new variable, because Kotlin say like I'm just going to show you. If I just had something like this, Kotlin is going to understand $user. It's going to think that dot is just something that you have put for design. It's not going to understand that user dot name is a variable. Like you're accessing the name variable from user. It's not going to understand that. So how do you tell Kotlin that okay, all of this is one thing together? You just put the thing which you wanted to take together in curly braces. So now Kotlin is going to understand, okay, I have a input of user, and I go to the user variable and then take the name from there, and that is the thing which I'm going to be putting it in here. We call this string interpolation. So if you have a single variable, it's recommended to just use a $sign, but if you have to access it from somewhere else, you just use the curly braces. So now let's print it out, and we should all have it as expected. Yep, as you see now, we have the border. It's printed out happy birthday, comma, and the actual name that I have passed into the function, which is minus. So we're up ready. Now it's time to draw the cake. So how do we draw the cake? It's just some commas, some straight lines, and symbols. So we know how to do them. So I just create another func to create the candles. That create candles, and the naming function, the naming is totally conventional, and it's up to you, and it's personal. You can name it whatever you want. I'm just coming up with random names. So fun create candles, and we usually have candles based on our age. So let's accept the parameter age as an integer. Once you're done, inside the function, it's just the repeat statement. As you might have already guessed it, we're going to be drawing something for multiple times. So inside the repeat, you're going to be repeating it for age times, and you're printing first the flame of the candle using a comma. You might have thought that okay, let's put in them together, but if you put them together, just imagine what you would get. You would get them vertically, but we don't want them vertically, we want them horizontally. So we would have to first draw out all the flame of the candle, and then we would have to draw the body of the candle. So let's just ask you to do this. Then after it's done, we're going to be creating a print ln, so that we are on a new line, and then repeat the same thing to draw the body of the candle, which is print a straight line. So if you did not know how I just did that, it's just shift followed by the backslash, and you would get this straight line, and this is just a comma. Now you can just call in this function print ln, just so that we can go to the next line, and just here use the create candles function, and I'd be 18 this year, so just put that in. And as you have expected, it did draw us 18 different candles. If you could, you could just count them, but surely there would be 18. Now that we have drawn the candles, let's move to drawing the layers of the cake. For that, I'm just going to create a new function, create cake layers. So here we would need to be taking in the age parameter, because we know to know the width of the candles, and then add some more for the layer. So I'm just going to accept in the age parameter again. But now, if you did observe the cake is not just a single layer of thing, right? You would have multiple layers for the height of the cake. So to accept that, I'm just going to take in one more parameter, layers. Like how many layers would the cake be of that? So I'm opening my curly braces, and you might have already got used to it by now of using repeat commands to run multiple lines of code. So the same thing again here, repeat, and I'm going to repeat this thing for the layers. First I'm going to write the code for repeating different layers. So how many other layers? It's going to repeat the same line of code. That's the thing which we want, right? Next, let's repeat for the different width. So repeat age time, but we just don't want it to repeat for the age times, right? Because we want the cake to be a little bit bigger than the number of candles. So I'm just going to give it age plus 2, and we're going to just print the @ symbol for the layer of the cake. Once we are done printing all of them in a layer, we're going to go to the next line for another layer. With that, we have defined our create cake layer. If you could just go through this code again, you would get it really well. That I'm just going to repeat for different layers, and when I'm drawing each layer, I'm just going to repeat a particular line of code that is printing @ symbol for age plus 2 times, and then I'm going to go for the next line so that I can draw the next layer. That's it. It's just very simple. Then I'm just going to draw the cake layer here. And if you did observe, we're going to be using the age twice in the same main function. So to maintain uniformity, I'm just going to define that as a variable. So var age equals to 18, and I'm sure you're already very well versed with variables by now. So instead of using it here manually, I'm just going to use the variable I've just defined. And layers, I guess I'd have 4 layers on my cake. Okay. Let's, Kotlin says that it could not find the thing. Could you just spot out where did the issue go? Yep, we did not use the word fun, so Kotlin doesn't understand it as a function. That's the where. So whenever you have an issue, Kotlin always tells you clearly what is it. Now let's run the code, and yep, if you see here, we do have it now printed to the console. We have some candles and some number of symbols for the cake design. So here I'm just going to turn now my font so that you could just see it a bit better. And now if you do see, the spacing and alignment are all well set, and let's just move the candles by a single spacing so that we get it much better. So when you're printing candles, I'm just going to print a single space. Yep, do the same thing for this as well, and we should be good to go. Yep, and now if you see, we have got the perfect alignment and the message that we got and which we wanted to create. So that's all, and you're now officially a master of Kotlin. Now let's get back to a theory, and let's just see how Kotlin and Compose work together. Okay, now we'll see about composables. Composables aren't something different. They're just functions, but these functions have some extraordinary power. They can emit UI. So for people, I just like to give a revision. UI is nothing but the user interface, or what the user can see on the screen. So if you need anything on the screen, you need a composable. That's right. Everything in Compose is a composable. From the text to your image to even in the whole app, everything is a composable. So let's see how a composable defined. They're defined the same way a normal function would in Kotlin, except we have a special annotation to tell Android Studio or Kotlin specifically that, hey, this is not a normal function, it's a composable function. So you need to run through it, then get to know how much is the different size of the widget and stuff, and then finally you need to draw that for me. So you're just telling Compose, hey, this is something you need to compose on my screen. So let's see. At the start, we had the @composable annotation. Next up, we have the keyword fun that we have discussed previously to denote any function in Kotlin. Further up, we have the composable name itself, but we have a small change here. Previously, when we were defining functions in Kotlin, we would always use the camel case, or when you had 2 or more words in a function name, you would start with a lowercase letter and the other words would start with an uppercase letter. But here, they follow the convention that any word starts with an uppercase letter. So here, composable name, if you observe, the C starts with a capital letter or an uppercase letter, and N starts with an uppercase or a capital letter. Next, we have parameter type. That is, you can add in different parameters to your composable function, but here we have a small interesting point to note here. When you passed in functions, you could even pass in functions into a composable function. For example, you can put a composable in a composable itself. You can take a composable UI and put it as the parameter for another function. Sounds cool, right? We'll see how to do that in a few minutes. You can also pass in functions into parameters, and next up we have the curly braces indicating the code which goes inside there. That is going to be the UI which is going to be drawn. One more point to note here that differs from Kotlin functions: you cannot specify a return type for a composable, because that's the twitch there, right? Composables emit UI automatically, so you cannot give any other type of return function. They always return a UI. So composables are annotated with @compose and are functions, but should not declare any return type. Let's see the different type of composables that are already available for us, and we need not again code them separately. And most of the times we use these in our applications and are the commonly used views that we need to use in our application. First up, we have the text. To display any amount of text or any lines of text, you can always use the text composable. We'll get to know about how do we define each of them and how do we utilize each of them in coding in a few minutes, but let's just get to know what each of them are. Next up, we have a button composable. You might have guessed it, it's just a material button that you can modify and customize it to your theming so that when the user presses it, some action goes on. Next, a text field. For people who aren't well into coding, it might sound new, but for people who are already aware of JS or HTML or other languages like React and stuff, you might have already known what is a text field. A text field allows you to enter any text like your name, your email ID, any text that you want the user to input using his keyboard, then you need a text field. Next, the most important of them all, without which we cannot live without, are images. So let's see how can we arrange these different composables within a screen. So they're all counterintuitive, so I guess I need not explain them, but just let's go through them quick. First off, we have a row. In a row, you can align objects or composables, rather I say, in a row. That is side by side or one to the left, one to the right, and so on and so forth. Next, we have columns where we can align objects one below the other, and they're in the vertical direction, and rows are in the horizontal direction if you would like to have it that way. Next, in a box, we align items or composables one on top of each other, like we stack them on top of each other. Next, the most important of them all, a surface. A surface you can imagine like a card for people who are migrating from views. So you can club in pieces of information or composables that relate to one another together on a surface or a card, if I can say it. So now that we have pretty much understood what a row, column, box, and surface, let's just go and look at a real application that you can connect with when you're trying to build all these. So here's an application that I've just designed for the purpose of this code lab, Portfolio-o-Matic. It's a beginner level project, and I guess all of you can follow along. It's just a simple application where you enter your information like your name, your date of birth, your email address, a website if you got any, the different projects that you have worked on, your awards, your experience, and a short bio that can be used by the Android operating system to give a sort of a portfolio kind of UI which looks really good on the screen. And then you can just share it with all your friends and family. So we're going to be coding this application. So let's just, before we dive in to really coding the application, let's look at all the different things on the screen that you can relate to when you're going through the theory. If you see in this first screen, this is a splash screen that we call it, that the first screen which appears when the application is launched and where you do in all the background tasks. So that's the splash screen. So the first here is the splash screen. If you observe, we have some text, but it's actually an image of the logo of the application that is put at the center of the screen, followed by a credit card, I can say, like where we give credit to the developer, that is here me, and it's consisting of an image and some text. So if you observe, the composables were put in a UI where one is above or below the other. So you must have already understood that we need to put it in a column. But the guess is here, we have some space at the top, we have the space at some bottom, and finally we have a composable. So we would need to put it some way that they're not just directly below one another, but they're having some spacing between them. Next, when we go to the next screen, here this is the page where we onboard the user or where we collect the information from him. You could think of it something like a login screen sort of thing, but here we're not taking any login, password or stuff. In this screen, if you observe, here we have the logo of the application again, but a quite smaller one. And then below that we have your information, text. So it's text, so you need to use the text composable. Next, if you see, these two were put one below the other, but these two are like they're combined together and they are having a circular surface put side by side in a row, if you could guess it out already, and this circular surface has an icon inside of it. Next, all this together is put together in a column, and that column also houses few more text fields if you just recognize them. So we're collecting some information from the user, so text field is your thing to go for. So here we have a few text fields. To just count them off, we have around 8 text fields to be exact. The first one is the name text field where we ask the user to enter his name. The next one is date of birth. The next one is the email ID. The next one is the website. And 3 text fields here are placed in the column, but they're each placed inside a row so that we can have them side by side. So this whole thing is a column, but inside a column you can have a row. That's the thing of Compose. You can put Composables inside Composables and inside Composable. It's like that old fun story where you had like wrapper, where you had a gift inside a wrapper, and that wrappered gift inside another wrapper, and so on and so forth, and you had 100 layers of packing. And the birthday boy was very eager to open them all out. So it's the same way here. You have composables inside composables, and literally everything inside Compose is a composable. So everything you see on the screen, every tiny bit of it is drawn using Compose. Finally, if you see here, we have the bio text field, which is taking it's just not taking one line of text, but it's taking multiple lines of text. Next up, we have the button, which I just themed it to look like it, but Compose has its own implementation for the button, but I've just themed it so that it looks good with the UI. So here we have a button, and inside the button, if you observe, we have a text containing next and an icon with the forward arrow. Once we click on that button, it should take us to this third screen, which is the output which the function is going to give us. And here we just have some text in green color, some text in orange color, which is a bit bigger, and then we have some text. And if you observe, we in the UI asks us to give a different color for some part of this text, so we need to give it in a row, and we need to split the text together. Or else you could use span text, but for this code lab we're not going to be sticking to that. We're learning the basics, so let's just use rows for it. Next, we have some more text, and here we have a text as a paragraph. Finally, here we have a clickable text that the user can click on and go to the website. Here we have a row, if you can observe it, because we have composables beside each other. Next, inside those we have surfaces, or as I said, cards, because they are relating things coming together. Like the 8 wouldn't stand out alone and it doesn't make any sense, but when you say 8 projects, it does make sense. So to club or put together composables which relate to each other or give meaning to each other, you would put them in a card. So here we're using a surface to contain them in a card. And then we have the same of 3, each for project, award, and experience. And inside that card we have a text and another subtext. Then up we have one more surface, because it's going to differentiate than what is currently there. So inside that we have a column, and the column is going to house a 2-line text. The first one is the title or the text which is going to tell what is that column for, and the other one is the actual data itself. Finally, at the bottom most, we have this Android logo at the left side of the screen, which is an image, and we have fun design at the right, which is housing the user's age, which we got based on the date of birth he entered. And finally, we have a floating action button that the user can click on to share the screen. Finally, at the bottom most, we have a column or the credit for the developer, where we just say made in India with love, and the copyright of the user application. And this is the app logo. So we're going to be just building this application within few minutes, and I hope you're all ready with the Kotlin basics and you have become masters at it. So it shouldn't be a problem. Let's just type in. Okay, now the first step to build an Android application is to open Android Studio itself. So you can either download the stable version of Android Studio from developer.android.com/studio, or you could download the Canary version. And the latest Canary version at the time of this code lab is Android Studio Electric Eel Canary 5. So I'm just going to go through a tiny peek at how do you download and install Android Studio. So just open up your browser and head over to developer.android.com/studio. android.com/studio, or you can just search Android Studio on Google. Next, if you're going for the stable version, just hit download Android Studio, go through the terms and conditions. Once you have done, just click on I've read and agree to the above terms and conditions, and then choose between the Mac with an Apple chip or an Intel chip. So if you're on Windows, you just get the downloader for Windows. If you're on Mac, you just need to go for this. You can just check this if yours is an M1 or yours is an Intel chip. Once you're done, you can just open the DMG and then just drag the Android Studio application into your applications folder. But if you're going for a preview, which I am going to be using, just hit the preview button here. And as you can see, at the time of recording this code lab, the latest version of Android Studio Canary is Electric Eel Canary 5. And I'm going for Electric Eel Canary build so that we have the latest preview options for Compose. So just hit the button, then agree to the terms and click on Mac with an Intel chip. You'll be asked to download it, so just save it somewhere where you can access it, like on your desktop or downloads folder. And then once you're done, just the zip will get extracted because this is a preview build. All the preview builds are in a zip format. Just copy or just drag that application folder into your application folder. Once you're done, you should be able to open Android Studio directly from your Mac. So I'm just going to turn it on. You should see the splash screen of Android Studio, and then within a moment you should be on this screen. So once you're on this screen, I hope that all of this screen is very intuitive and you can understand it, but let's just get a quick overview. You can just create a new project with this button. You can open an existing project using this button, and then select the folder containing the project you're working on. And you can just go through many other tools like SDK Manager and Virtual Device Manager from here. If it's your first time opening up Android Studio, you would be directed to follow along of the instructions to install the required repositories and system images to run Android Studio. So just review them and just click on next, and click on finish. And you should be up and ready with Android Studio. So once you're on the screen, the first step to do is click on new project. And because we would be targeting Material U theming, or as I can say in code names, Material 3 theming style, I'm just going to select the empty compose activity Material 3. As you can see, it's still in preview. So hit next. Here is the important step. You need to give the name for your application. Here in our case, it would be Portfolio-o-Matic. The next one is the package name. So here's where it's a bit confusing, but it's so easy. So say you're working at an organization and this application is a part of your organization. So let's, I'm just going to give an example. Say I am working at a company like google.com, then the website URL would be google.com. So if I was working at Google, then the URL would be google.com. So then the package name would start with com.google. And here, since it's my personal project, I'm just going to give it com.manasmalla because my website would be manasmalla.com. So it's com.manasmalla followed by a dot, followed by your application without spaces and capital letters. So here Android Studio has kindly added in these underscores for me because of the dashes in my product application name, but I just prefer not to have them. Once it's done, just give the save location. Here it's in the users folder of my home folder, and inside of the Android Studio projects directory it's going to create if it's your first time. And I've just created a subdirectory called the Buildathon, and there the project folder is going to have the name. So just go with all the defaults if you're just unsure of what they are. Here we have the option to change the minimum SDK, but Android Studio gives us the default of API 24 or Android 7 Nougat. Let's just go with the default because most of the features that your app might run should have a minimum dependency of API 24. But don't worry for the people who aren't still updated to Nougat, because here it says your app will run on approximately 92% of the devices. So we're good to go. So just leave them default and just hit the finish button. With that, Android Studio should be generating all the files and project structure that are required for your Android app to successfully run. So let's just give Android Studio a minute and we should be up and running. It could take 2 to 3 minutes, or it could even take till half an hour based on your system requirements and system configuration. It mainly depends upon your RAM. So I forgot to mention it, but I guess you would have already checked it. To run Android Studio, you need around minimum 4 GB of RAM and 500 MB of free hard disk space. So yep, my project has finished creating my project. So before we dive into any of the code, let's just get ourselves familiar with the layout of Android Studio. Here at the top, you can see that Android Studio is showing us the directory we are in. So we are in the Portfolio-o-Matic folder. Inside that, we are inside a folder called app, and in that we have a folder called src, and the subdirectory again is main, and inside we have a subdirectory named Java, and inside we have folders for the package name that we have just now named, that is com and Malla, and then Portfolio-o-Matic, and inside that we are inside the file named main.activity.kt, which is shown to us here on the right side, which is the editor. Next, here we have the project pane open. If you just didn't have it open, just click on the project button and you should see it up. For people who couldn't have a successful Gradle build, you probably might be in the project view, but just change it to Android view using this drop down. Once you're here and you have successfully built your application using the make project button, if it did not automatically happen for you in the first time, then just hit that, and then you should be able to view the screen. So here you can see we have mainly two subdirectories, parent subdirectories, the app subdirectory and the Gradle subdirectory. In the Gradle, we are just bothered with these two files, build.gradle and build.gradle, but if you can see, the one is having the project level and one is a module level. So we'll be mostly dealing with the module level one. We'll just see why do we use it and where do we use it. But first, let's go through the app folder. In the app subdirectory, we have three subdirectories. One is manifest, one is the Java folder, and other is the rest folder. You might be wondering, like, I've selected the project to be a Kotlin project, and we have here .kt signifying a Kotlin project, but why do I have Java? Because Kotlin was built upon Java, so you do have the Java folder still in Android. So inside the Java folder, you have the application application name you have given here, com.manasmal.portfolio-matic, and inside that we have the main activity.kt, which is the entry point to your application, and you have a subdirectory ui.theme, which houses three files. So we'll get to know what these three files mean and what you could do with them in a few minutes. The other two folders are for testing your application, that is instrumented test and unit test. We'll get to know about them in a future session, but for now we can just leave them as it is. Next, if we click on the small arrow icon beside the res folder, it's going to show up us 4 more new directories inside of res directory. So we have the drawable directory, the mimap directory, the values directory, and the XML directory. So the XML directory is just going to house some rules that Android is going to be using to build an application, and so that it runs well. The values directory is also similar, but it's just going to host some colors, some of the text values and themes that Android Studio is going to use to build our application. The mimap folder is not much manually handled upon, but we're going to be putting all our icon related files in there. The drawable folder, if you did have an idea or if you could guess, it's just going to house in all the images that we're going to be using for this project. So that's about the app directory. Now let's go into the Gradle scripts directory. So the main file which I told you, which is going to be handling, is the module level build.gradle file. So if you just double tap to open it, you would find that it contains all the configuration settings that Android Studio has already given us so that this app can run. See, it has given us the application ID, the minimum SDK version, the target SDK version, which platform would you be building for, and all the other things that are required to get your project up and ready. But here, if you see, we have the dependencies section, which is the most important one and which will be handling around the most, is where all the snippets of code that Google has already written for you so that it can save you a lot of time, all those are imported into your project from here. So if you need something else from Google that you need to import in your project, say I need navigation or I need some more icon set for that project, then you can just import them in here and you need not spend days of your life trying to write them again because Google has already covered. So that's the thing. And the build.gradle file of the project level, we just have some plugins and the version of Compose that this project is using. You can just update it from here. So now that we have gotten an idea of the file structure of Android Studio, let's just get to know about the different icons that you can see at the top here. SDK Manager is just used for installing sources and platform specific tools that you need to build for Android. You can just click on it and you should see a pop-up having all the SDK versions or Android versions, I can say, that you could build for. So here the latest is Android Tiramisu. We'll be getting Android 14 soon, but here we have sources for 13, 12, 12L, 11, and so on and so forth. Next, you could also click on this ABD manager. Oops, sorry, I just clicked on the wrong button. You can just click on the ABD button, and here it shows you all the emulators, or as I previously said, an emulator is just a simulation of a real device on your laptop, of a real Android device on your laptop or computer. So you can just create emulators from within here. You can just click on the create device button and then just go through the humongous list of devices that Android Studio supports and that you can simulate. You can just select any one of them and then select the system image, just hit next, and then you can just set them up. It gives you a lot of control of how you can create your emulator, the RAM, the internal storage, the SD card and stuff. I already have 3, so I'm just happy with them. Whenever you want to run your project, you just select the target device that you would want to work with. You can also pair your devices using Wi-Fi, or you can just connect your physical device at this step to your computer using a USB cable. Once you're done, your device should pop up here, and then you're ready to go with just clicking this button to run your application. So now let's deep dive into some of the code snippets. The first one is Android manifest.xml. So this manifest file is just some pre-handed data to the application, to the OS you're giving, that okay, hey, this is my application, this is going to have this icon, and you need to show this in the app drawer, and when the button is clicked in the app drawer, you need to go to this particular page. Here we can tell that Android Studio is asking the app drawer to go to the main activity, as we have the launcher intent here. So with that, we are off, good to go, and there is nothing much more to convey from this XML file. And the only other situation where you would be handling it is when you have an application. We'll get to know more about what is an application file, but you can also add in another icon to your app through here. Next up, the main file or the main activity. It's so intuitive. The name main activity says us that this is the activity which is the most important or the main one. So whenever your application runs, it's going to call this file. So in this file, it might sound like a humongous amount of code and you might get confused or get scared as well, but it's so easy. Let's just break it down. So we've already seen the classes, and we already got to know that classes are just it's just going to contain different functions and variables that you can use for your project. So the same way, the main activity is defined as a class because it's going to house different variables and functions that you will be using to design your screen and do different functions like getting stuff from the background or taking pictures and many more. You already know how to use your Android device. I think I don't need to tell you it. Next, if you see here, the main activity class is getting derived, or it's being instantiated from a different type of a class called component activity. So why is it doing that? To draw something on the screen, you would need a hell number of lines of code and functions and methods that you need to actually draw something on the UI or the screen of the user. But Google has you covered there, so it has already created something called a component activity that automatically gives you all the functions and parameters that you can use to draw something on the screen. So this component activity, I can just click on command click or control click, and I can see all the code that Google has already written for you that exists inside of this class. As you can see here, it's a class that already extends one more class, and that implements a huge range of classes. So if you can see, it's a class which is extending another class, and it's implementing many other classes. It's a very big class. You do not want to write these many lines of code just to look at a particular screen. So Google already has you covered. So we're just utilizing that same thing here. So we are creating a class called main activity, which is just deriving all of its stuff from component activity. So it's just taking a copy of component activity and changing itself so that it can be a self class. So I can just give you a simple example of how you could relate this to. Most of us have already been used to Google Slides, I guess, during the pandemic season. So in Google Slides, say I sent you a slide, but you could not modify that slide on yourself because I did not give you permission. What would you do? You just create a copy of that slide on your Google Drive and then edit that file to match your requirements. So the same rule applies here. Main activity cannot automatically create its own code, or it cannot change the code in component activity. So we're just taking a copy of component activity and using it and changing our stuff so that what we want is what we have. So here if you see, we have the onCreate method, which is inside of the component activity. It's a function which is just run whenever the screen has going to be composed or something is going to be drawn on the screen. But because this onCreate method is already defined in the component activity class, we're just going to override it. We're going to modify it. We want to change it so that I can display what I want to, not what is already given by Android itself, right? We don't want all of the applications on the Play Store to have the same text. It wouldn't be possible to develop many applications as we have now. So that's why we have this override keyword here. We're going to change something in the parent class, and then this function, it's taking some type of a parameter. It's called saved instance bundle. We need not know what it is for this code lab. It's out of the scope. Next, it's of a type bundle. Bundle is just Android's way of saying that I have a lot of data which I just put it in one folder. Next, if you see, it's calling super.onCreate. So this line is just saying that, okay, hey Android, just go to that onCreate function inside of component activity. So first do everything that already component activity has told you. Then after it's done, just do what I am telling you to do. So after that, what we are telling you to do, we're just asking you to set some content. So you want to draw something on the screen. What we want to draw something on the screen. So we are having a Portfolio-o-Matic theme function. You might see like, okay, this doesn't have parentheses, this doesn't have fun word, or it has some parentheses, curly braces, but it again has code inside it. You might feel this might be something new, but no, all these are actually functions. But there's a small exciting point in Kotlin that I would like to share to you. Whenever you have a single parameter inside of a Kotlin function, but that function is the only one existing in the parameter, or it's the end last one, then you need not put that in parentheses. You can already directly call it without the parentheses using just curly brackets. So we have a function called Portfolio-o-Matic theme, and we'll just get to know in a minute that that is just giving our app a material you designed. Inside of that, we have a surface. We already discussed what surfaces were. Surfaces just give a room for Compose to lay out your component, composables, sub-composables that all relate together. So inside of that surface, which is currently taking up now the whole max size, we'll get to know about modifiers very soon, but it's just going to take up the whole screen of the user, and it's going to have a color of this particular thing which it's getting from material theme, that color scheme, the background, and it's just a color, and that's going to host our composable greeting. So if you see here, the greeting is just saying, having a text, and it's accepting the name as a string, which you have already previously seen in the Kotlin playground, and it's just putting that name inside and it's displaying as the text. So if I just input Android, then it's going to say hello Android. So in Compose, the biggest advantage is you need not run your application on an emulator or on a physical device to test your application. Hooray, the build times are done. You can just simply look at how your application is going to look even without building it. How do you do it? You just define a preview function. Apart from your composable, you also define a preview composable just by adding the annotation @preview, how you just do a, like @compose, and inside that you'll just give the composable that you want to test it out, and just click on the split view here, and let's just click on build and refresh, and you should be able to see how would this composable be looking if it was actually built without having to build the whole application. Now that's Compose, and that's going to save you, I'm telling you, it's easily going to save you around minimum 24 hours of time if you are rather building the same project on View system. So as you can see, it has already built the project. It's just rendering it. It would just take 1 or 2 minutes, and here we have it. It's has already rendered the whole thing for us, and as you can see, because we have the input as Android, it has rendered hello Android. So that's the power of Compose. So now let's see where is it getting this Portfolio-o-Matic theme from. So if you could just see, we have that in the app ID folder, and inside that we have the UI.theme folder, right? So just go there and let's just go through each of these three files. Let's open them up. So let's start off with color.kt. So the color.kt file is just pretty simple. It's just housing different colors that you might need in your application. So if you have different colors that you would want to use, just put them here. Just define them as a variable, but they're not only pure primitive variables, they're just variables having the type of color, which you can just define using the color class followed by the 0 into ff followed by the hex code. The ff in the hex code just tells you that you'd have an alpha of 100 or 255 alpha value if you're going for RGB. So that's how we define colors. Next, let's go to the next file, which is the theme.kt file. But before we go in, let's just see one of its dependency, which is the type.kt file. So here, if you see in the type.kt file, we just have a typography, or in other words, I can say a font. So here in this file, wherever you want any font, custom fonts, or if you want to declare a custom typeface for Android to follow, you can just use it in here. You can define the size for each of the different categories of typography that material design follows. Here we have display large, display medium, display small, like large, medium, small variants of display, headline, title, body, and label. You can just head over to m3.material.io to understand how each of them work and where are to be used where. So let's just close this file, and the color.kt file. We'll work on them in just a minute. So here this theme.kt file is just hosting all of the different dependencies together that material theme can use to build the theme and use it for our application. So here if you see, we have a composable fun Portfolio-o-Matic theme, which we have just seen previously. I'm just going to update this so that it matches our application name. And we see it's having a parameter of dash theme, and it's a type of boolean. And as you can see here, we have already given it a default value. So you can give default values in Kotlin functions so that you need not always give it. If you do not provide any value, it's already going to take the default value in. Next, we have the dynamic color variable, which is also a type of boolean, and it has a default value of true. Finally, we see we have the content variable. It's just a function, but if you see here, it's a composable function. So we are taking in some UI as a parameter. Just imagine it if you would have to do this in View system. How crazy would it be? So whenever you want to take in a composable function or a function itself as a parameter, you use the notation parentheses followed by an arrow symbol composed of a dash followed by a greater than symbol and followed by the word unit. But because it's a composable one, or the content is going to be some UI, we tell Compose that, okay, it's not just a normal function that I want to accept, it's a composable function that I need to accept. Even if I did not use the annotation here, it would still work, but it's always best to annotate our functions. Next, we have the color scheme, which is being built from the different colors that are defined at the top. You can just navigate top. You can see we have two color schemes, a dark theme and a light theme, and we have different colors that are being defined over there. So we're just building a theme out of those. And if the user is on an Android version greater than Android 12, then we just use the dynamic color system if he did enable it for the application. Next, we just set the navigation bar color and the system navigation colors to the primary color of the app so that they all match together and look really good. Finally, we see we take the implementation of material theme. We don't need to write the material theme whole composable on ourselves. It's already given default by Google, so that's one of the biggest advantage. We can reuse code snippets. So here we have the color scheme, and we're just passing in the color scheme we have just generated. We're using the typography that is defined in the type.kt file, and we're using the content to put it under the material theme content. So just now that we have modified the name, as you can see, it's already telling us that it's never used, and most probably, yeah, it should show an issue here. Let's just fix it out. It's Portfolio-o-Matic theme, and the same thing changes here as well, and we're good to go again. So with that, we have just gotten a basic idea about how Jetpack works and how Compose can handle everything together. Now let's just start building our application. So I already have some code snippet that I would just like to copy and paste in here. So as you can see, I have some colors for the application that the application uses. So I'm just going to copy them and paste them in the colors.kt file. If you would already expected it, you would already get all of this code on GitHub, so just take them from there. Next up, if you go to the theme.kt file, before we update this file, you just go to type.kt file and then drag in and drop in all of the code which is responsible for adding some cool fonts. You can download and install any font and compose in your project. So simple. We'll just see how to do in a minute. So I'm just going to override all of this code with the ones that I've just copied. Yep, that's great. So let's see how it all works together. Okay, before we go in, let's just fix all these errors. And the first step in fixing all of these errors is installing the fonts in your project. How do you do it? It's so simple. Go to the res folder and just right click on it and just click on new and Android resource directory. Once you're there, just type in the word font or just select font from the drop down. Once you're there, just click on OK and you should have a new font folder in your res. Once you're done with that, just drag in all the fonts you have. Just gonna them in. Okay, here I have them. So just go to them. You can install fonts either in TTF or OTF into your project. So just copy all the TTF and OTF files and just paste them in the font folder. And with that, you have automatically installed your fonts in your project. But to start to use them in Compose, you just need to define a font family. How do you do that? It's so simple. Use a variable, and then because these are constants, just give them in uppercase, followed by an equal to, and the font family variable is the one which you require, but as you can see, it's shown in red. So whenever you have in Android Studio, whenever you have something with a red squiggly line, it means you have either done some mistake intentionally or you forgot to import something. So in our context, as you can see here, it says that none of the following functions can be called with the arguments applied. That is because it did not understand the list of these fonts, because these are also in red. So first we need to fix them and then we can come to that. So here if you see font unresolved reference font, and that is because we did not import the font file. Like there is a Kotlin file written by Android for declaring fonts, and we did not import it. So there are some files that need not be imported, like variables and functions and stuff, but some do need to be imported. So here just click on import button and then it asks us to choose one. We're going for the first one. And as you see, automatically when we imported this, Android Studio automatically understood what we are trying to do. We are trying to create a font family. So just do the same for the others. You can just click on option enter or alt enter on your Windows. Then just import the first one, and you have declared a font family. So it's just the font family, and it's housing a list of different fonts and their variants. So you have different weights and styles that are just used to define here, and that's it. It's so easy to define a font family. Once it's done, I just put them together in the typography, and don't think that I've just written all this code. I just copied and pasted them from the Material 3 implementation. So you can just go to Material 3 theme builder and just it's going to create all this code for you. It's going to take in the font family that you have just used and gives it how much size does it require and stuff. So just copy and paste that. All this code is available to you on GitHub, so just feel free to check it out. Once you're done, we need to start utilizing the thing which we have just made changes to. So I'm just going to change the typography to match the same. So we wanted to go for the Portfolio-o-Matic typography. Next, let's also update our color scheme. So whenever it's primary, we want it to be green color to match the UI design that we have been handed over with. The secondary color would be orange, and the tertiary color, I'm just going to change it to green 7. And then let's just define the background color. I'm going to define my background color as green 10, and then surface color, it would be green 20. Yep. With that, I've just defined my color scheme, which I'm going to be using when building this application. Now I'm just going to reload the project. So before we do that, let's start on working on it. So if you just remember the UI and the splash screen, we had the image or the logo of the application at the center and a credits card at the bottom of the screen. So let's start working on it. So I'm just going to delete this existing ones as we do not use them, and then remove this as well because it doesn't exist now. So just to make my code clear, I'm going to put them in different packages. So I'm just going to go here, click on tree appearance, and then choose compact middle packages. And inside this UI folder, I'm just going to create a Kotlin class named splash screen. With that, I'm just going to go back to tree and just enable it back. I just did that because previously the UI.theme was compacted together and I could not create a file inside the UI folder. But now that I've created something in there and there are two files in the same directory, it's not going to put them together like UI.theme. So now that we have created a Kotlin class, let's start declaring our composable. So I'm just going to declare it using the composable annotation followed by the fun keyword, and it's our splash screen. So I'm just going to use the name splash screen itself, and I should have imported it by mistake. Let's just remove it. So in our splash screen, what do we have? We have an image and a credits card, and one are below the other. So what is the composable that we need to use? You must have guessed it right. It's the column composable. So I'm just going to define in a column, and inside of that column we have an image. But if you have guessed that you can just put image and just give the resource for the image, it's not going to work. You need to give it a painter. So I'm just going to use the keyword painter resource, and it requires an ID. But before we start even writing this code, we just did forget to do one step, which is actually adding the images to our project. So just grab your hands on your project files. I have them here. You can either just copy and paste them, or else you could just click on resource manager over here, click on the plus button, click on vector asset. If it's a vector, we always prefer vectors, or you can just click on import drawings. I'm just going to import all my vectors first. So all of them are local SVG files. So just select them, go to the location of them, and then select them. So here we have them. So just import it up, click on next, and click on finish, and Android Studio should automatically import them. Just do the same for the others. So I just have a few more of them. I'm just going to copy and paste them in the drawable directory. You just go to project, and if you could see, you just got that new imported asset here. You're just going to copy and paste the remaining. So with that, we have all the images to work around with. So here the ID. So how do you get the ID? The image is located in the res folder, so that we do not using the capital R. Oops. And then inside, we are inside the drawable folder, so we go inside there. And then the image which we need is the Portfolio-o-Matic image. Next up, the content description, just app logo, because for people who need accessibility or the talker on the screen, so it's not going to automatically understand our image, so we just need to give it some text to read out when this image is being displayed. Once you're done with that, you can just show a preview of the same by using at the preview notation followed with @compose fun splash screen preview. The naming convention for previews is just the name of the composable followed by the word preview. So it would be splash screen preview. Next in here, I'm just going to use the Portfolio-o-Matic theme, and inside I'm just going to call the splash screen composable. So let's go to split screen and let's see how does our composable look. Oh, okay. Oh, yep. Android Studio forgot to remove the old import statement. So with that, let's just click on build and run again. Sometimes you need to help out Android Studio. It's not that clever yet. Okay, so let's just click on the refresh button. Okay. Now there might be some glitch, but I guess it should be fixed in a minute. Let's even add in our credits card, but the credit card actually is composed of an image and some text, but because they were in different formats, I just prefer to have them separate. And because of all the complexity that it involved to bring it together, it's a bit out of the difficulty level for this code lab. So I already have typed all of the code and it's available to you on GitHub. So let's just copy and paste all of it in the credits card.kt file, which we'll be creating in a minute. So just go to the project folder, just go to the UI folder, just create another Kotlin class and let's call it credits card. I'm just going to copy and paste the code. Let Android Studio import all of the statements by default. If you did not have it enabled, just go to Android Studio, click on preferences, and then in the search, just search for auto import. Then you should already find it here. And then under the Kotlin section, just select add ambiguous imports on the fly and optimize imports on the fly and just hit OK. With that, automatically, you need not always click on option enter, and automatically Android Studio should be able to import all the ambiguous ones. But some of them which are a bit confusing for Android Studio, you just need to do them by manual. So I'm just going to import all the manual stuff in here. And with that, we have the code for the credits card, and as you can see, it's just a composable, but it's using a custom layout. I'm not using a row, nor a column, nor a box, nor a surface. I'm just using something custom because I had to measure the size of the text. That is, I could place it with the available width and then take that height of the text and then put it for the image. So I had to do a lot of calculation for it. So I just had to use a custom layout. This is a bit out of the scope for this code lab. That's why I've just copied and pasted the code, but we'll surely discuss this a sooner day. Yep. So our issue got resolved by now. Android Studio understood what we are trying to do. So we have the image. Perfect. Now let's even add in our credits card. And let's just refresh it so that we can see how does it look. And voila, we have it. But as you can see here, we still did not achieve the spacing, and if you did observe it, Android Studio shows us preview using the least available space. Like it just takes the space how much is ever required for that composable. So that's why we are not always getting the full screen width or the screen height here. So now it's time to fix that up, and before we go there, we need to learn something called modifiers. Modifiers are powerful tools in Jetpack Compose that allow you to modify your screen. So it's intuitive from the name itself. Modifiers modify your screen. We have tons and millions of modifiers out there, and I guess I won't be able to cover all of them in this session, but we'll be covering all of the important ones. But just a note before I start anything with modifiers, I'd just like to tell you that modifiers are also functions, and they're functions that can be chained together. Like I could have a function run, and then once the function was finished, I could use another function on it, and then take the output of that function and then put it in another function as an input, and then continuously keep on looping it. I can chain multiple modifiers together to get the layout I require. So let's see how do we use modifiers. Modifiers can be used on any composable that do accept them. All of the inbuilt composables already accept modifiers by default. So I could just do them by adding the parentheses or adding the word modifier in the parentheses, saying modifier equals to modifier dot. And as you can see here, we have tons of modifiers, and we'll just see what all we use. We use the fill max width modifier to ask the column or the composable to take the entire width of the screen. We can use the fill max size to ask the composable to take the whole size, that is the width and the height of the screen. The padding modifier, for people who are new to coding and don't understand the word padding, it's nothing but spacing or the space around a composable in layman's terms. Next up, we have the fill max height, that is just used to fill max height. And for people who are wondering where did margin go in Jetpack Compose, that's where we have the Q. Because padding can be also used to give margin. Spacing could be given inside the composable or outside the composable. So it depends on, because I told you already, modifiers are just functions that can be chained together. So the correct order of modifiers is going to give you the exact UI that you want. So if you give the modifier of padding before another modifier, that is going to act as a margin. If you give it after the composable, it's going to act as padding or the space inside of the composable itself. Next up, we have the width modifier that is used to specify how much width it should take. And here, for people who are coming from web development or from Swift development, uh, we don't have pixels and other units. We have another unit called DP, which is just standing for density pixels. So what Android does is it just takes your screen size and screen width, then tries to understand the density of the screen, and then uses that density to convert from pixels to the ones that are best on your phone. So we use density pixels. It's very easy to define DP. You just use like 8.dp, 12.dp. It's the same as using pixels. Instead of px, you just use .dp here in Compose. For people who are migrating from views, we used to use 12dp and stuff in the XML, but now it's 12.dp, 8.dp, and so on. And as you can see here, we have different iterations of the same padding modifier. You could give a particular padding on all the sides, or you could give them at the left, right, top, bottom, or you could give them for horizontal and vertical and stuff. And the same, we have a height modifier for telling the composable how much height to take up, or you could just give it the wrap content height, the aspect ratio. All of these words are very intuitive. Like you could set a background for a composable using the background modifier. You could clip the modifier to a particular shape using the clip shape modifier. You could give the size of the composable, like the width and the height combined together if it's a square or circle. You could give it the offset, or how much should it move from the position that it's given, like if it could go up an 8 pixels without changing the other composable's position, stuff like that. You can just go through this whole list, and it's so intuitive that you can understand it on your own. Like we have the alpha or the transparency modifier, the blur parameter, the clickable modifier. You can just add this to add clickability to any of the composable. You can do that same for semantics as well. You can just go through all of these modifiers and just play around with them to understand how they work. But here in our case, we want the splash screen to take up the entire screen. So what would you require here? You must have guessed it right. We would require the fill max size modifier. So let's just import it in. Okay, now let's just click on refresh button to see the update. And as you can now see, we have the screen now, finally. And if you feel that you're just having a transparent background for the screen, you can just change that using show background to true on the preview annotation. So, and you can already see it's already updated to give us a white background by default. Next up, the next thing which you need to do is give in some spacing on the left and the right for the image, and then send this to the bottom. How would you do that? It's so easy. First off, let's define some padding for the entire screen. So I just do that using dot padding, and let's give it an overall padding of 24 dp, and then refresh it, and we should see a spacing of 24 pixels or density pixels on all sides. Yep, it looks better now. Now the second step is to increase the spacing more, but only for the image, and send this down. So you might have already guessed it, we just add the padding modifier for the horizontal axis to the image itself. So we just go for modifier equals to modifier.padding, and then we give the horizontal and vertical version of the padding modifier, and I give it a padding of 48 dp on both sides. Now let's just refresh it to see the update, and yeah, that looks great. It looks really great. Next up, the thing is, we need to move this to the center of the screen and this to the bottom of the screen. How do we do that? We have the spacer composable, as you might have already guessed it, but here comes a small catch that you need to get. The spacer modifier, the spacer composable takes in a modifier, and you need to give it a modifier in terms of height or width, depending on if it's a row and you need to give spacing, it would be the width modifier, or if it's the column, then you need to give it the height modifier. But because you're in a row or a column, we have a special modifier called weight. What does weight do? Instead of giving it a default value like I need to go to take 60 dp height or 80 dp height, the weight modifier is going to take the whole screen. It's going to remove all the composable height and width, Once it's done, it's going to take, like in our context, let's go for it. It takes the screen height, subtracts the height of each of the composables present in the column, then it's going to take up whatever remaining space it is. So here we need two spacers, one at the top and one at the bottom. So each would take a value of 1f, or both of them would be having the same priority. The 1f in the weight stands for the priority, or if it was in the ratio 3:2, then the space would be divided in the ratios 3:2, or the thing. So how do you know what would be the ratio of the spacing? It would be like you just add them up and then you take one over the other one. Like say it was 2 and 3, then it would be 2 plus 3, 5, and then the first one would be 2 by 5, the other one would be 3 by 5 of the space. But here it's just half and half. So now let's just run it, and we should have the UI that we expected it to have. Yeah. So isn't it starting to look like a professional level application? I guess you do say yes. So now we have finished the splashing, but you might feel there is something missing, and yes, we do. We forgot to give it the background. So I'm just going to wrap my whole column inside of a surface, and this, using the surface, we're going to leverage the color option, and the color option is just going to have material theme dot color scheme dot background. Now let's just refresh it up, and we should have the background applied. Yep, it's a bit light, but yep, I'm able to see it. So let's just close this up, and let's head back to our main activity. So when the app launches, you should go to the splash screen, but as soon as the splash screen is done, you should be able to navigate to another screen. But how do we do that? If I try to use the intent, then I should have another activity. But in Compose, everything is a single activity. So how do you work around it? That's why we have something called navigation in Compose. It's an API that was developed by Google to help us navigate between different composables. Now let's just see how do we implement it. So to first implement navigation, go to the project window, into Gradle scripts, and go to the build.gradle file of the module. And there, add in the implementation for navigation API. How do you do that? Just go for implementation and then remove the parentheses and now add in single quotes. Start typing Android X dot navigation, and then you should see Android X dot navigation compose 2.4.2, or whatever is the release version at the time you're coding this application. For me, it's 2.4.2. Once you're done with that, I'm just going to update all of them. They were not updated. I'm just going to change them all to the latest version. And once you're done with that, just click on sync now, and it should sync all the changes. Here it says that there is a new version of Compose available, 1.2.0 RC01. So to update that, just go to this page, the project level build.gradle file, and then update it in the RC01. Yep. With that, we should just get another ping from Android Studio asking us to just do the Gradle project sync again. Okay, so here it says this, so let's just do it again. Okay, while Android Studio works on that, okay, it says already finished. Great, wonderful. So the first thing what you need to do to implement navigation is, again, go to the project tab, then in your UI folder, create a new Kotlin class. We call it the name of the application. Here it's Portfolio-o-Matic, followed by nav graph. So the typo, and then it's not a type of a class, it's just a composable function, and then we just annotate it with @composable, and we give it the parameter. Now this nav graph should accept in a nav controller. Nav controller is just a variable that you can use to control the navigation in your composable. So how do you define it? It's so easy. Just give it a name of nav controller, and it's going to be a type of the nav host controller, and it's going to always take in a default value of remember nav controller. We don't have any navigator, so just delete up that variable, and you should be good to go. Inside of this, you just define the nav host composable, and for the nav's controller parameter, you just use the one that you have just now created. For the start destination, we need to give it a string. As you can see here, it's a type of a string, but just to make sure that we don't have any typos in later future, I'm just going to define a set of constant values. Constant val splash equals to splash, and you can use lowercase, and splash underscore root. So instead of using the literal string, I'm just going to use the implementation so that I don't face any typo issues in future. Next, the builder, we're just going to use the function notation instead of using it as a variable. So here we see we have a nav graph builder coming out of that function, but let's just use it. So we use the DSL composable, and inside that it's going to accept the destination string. So we'll define one for splash screen root, given the parentheses. So it's going to create as a composable function inside of the nav host that I can later use to go to the splash root. So when the user wants to go to the splash root, what should we show him? The splash screen. So just call in the splash screen composable in there, and you're all set. But I don't guess you would want to always have the splash screen, right? So you would want to update it after a few seconds. So how do you do that? It's so easy in Compose. So what you do, you just define it there, but before it, you just create a launched effect. That is actually what we are trying to do, is we are wanting to ask the system to wait for a particular period of time before going to a new screen. So to tell Compose to do that, it's called a side effect, because your app might go out of screen, but still the code might be running and the screen might get struck, or the user interface might be not good, and that can cause Android to close your application, and that's not very good in terms of UI and UX. So here launched effect is going to take in a key. For now, just given it a value of true. We'll learn more about side effects in a future code lab, but that is currently out of the scope of this session. So launched effect is just going to allow us to launch a Kotlin coroutine. If people who are Kotlin developers out there, it's just going to launch a coroutine. So we're going to be launching the coroutine delay, which is just telling the computer, okay, the Android operating system, please wait for 2000 milliseconds before running the next line of code. And what is the next line of code that we wanted to do? So we wanted to navigate to the next screen. So to tell it to navigate to the next screen, I'm just going to use the nav controller that we have just defined, and then use the dot navigate method on it. So I'm just going to use the dot navigate. But before we do that, we should have another screen on our app. So I'm just going to define one more, composable. So let's define the root for it. So it's going to be a constant val, and then information root. I'm just going to type. So now let's use it up here. And so when we click, when the 2000 seconds is done, sorry, 2000 milliseconds is done when displaying the splash screen, we want to take the user to the information root. So let's go there using just, so we just use the navigate method on the navigate nav controller, and we pass in the root that we wanted to navigate to. It's that simple. So now we just call in this whole nav host in our main activity. So it was called portfolio nav graph, and you're up and ready. So if you run the application now, you would get the splash screen, and exactly after 2 seconds it would navigate to the information root. Now it's time to build the second screen, which is the information form collecting screen. So let's work on that. So let's add in a new Kotlin file. Let's call it typos information screen. So let's change it to a composable function, annotated with @composable. And if you did observe our UI, the main root composable was a column, because we had each below the other, and we needed to take the whole size of the screen. So modifier equals to modifier dot fill max size, and let's give it a padding of 24 dp. Next up, let's start going to the subcomponents. The first one, we had a row, so let's code that in. We take in a row, and we're going to ask the row to take the maximum available width. So we give a modifier there as well. So modifier dot fill max width, and inside the row, what do we have? At the left side, again we have a column, and at the right side we have the image button for asking the user the profile picture. So First we'll write the column, so we have another column inside the row, and inside the column what we just have is the image, and the images of the app logo itself. So we'll just define the painter resource as we have done previously, r.drawable dot, okay, let's just wait for Android Studio to import it and understand what we mean. Oops, just a minute. Android Studio gets crazy at times. Drawables, that's what I want. Okay, then let's just manually import it. Import com.manasmalla .portfolio-o-Matic.r, and automatically we should get what we wanted. So inside that we want the Portfolio-o-Matic image. The content description is Portfolio-o-Matic logo. Next up, in the column we have some text. So we're going to be using the text compose, which is going to accept this type of string, and we just have the text your information. Let's just define the skeleton of the screen before we try to do some kind of UI theming. Next up in the row we have another image, or first we have the circular surface. So let's define it, surface, and then we take in the color. The color was just green 20, and the shape was a circle. Then height, so it's the modifier, we need to use a modifier to set the size or the height and width. In fact, we're just going to take it a 120 dp image or size, and then we would want it a padding of 48 dp inside. Next, inside we just have an icon, and the icon, just I'm going to import it. So it takes in, let's see what all the parameters does it require. It needs an image vector, so you can just get it from icons dot rounded dot camera, but it doesn't exist. So what did I tell you before? We need to import it in. So just do that up, write another implementation Android X material icons extended, and then just click on sync now again, and then we should have, yep, camera on. That's the one we were looking for. Next, it also needs a description. So content description, let's just give it add image, and it should have a color of, or tint rather should I say, for an icon of green 70. Now let's just see the progress that we have done in a preview. So I'm just going to define a preview for it. So @preview, sorry for the typo again, Composable fun information screen preview, and then inside the preview let's call in our portfolio theme, and inside the theme let's call in the information screen. Now let's go to split and see how does it look, and let's just add in the background so that we get a bit more clarity. Let's just give compose a few minutes to just build it up, and we should have it up and running. Yep, we are getting close. I know that it's not that the UI we have desired, but we're getting close. So the first step that we need to change here is we need to give it a particular width and the height for the column. So I'm just going to ask it to take up half of the screen. So how do we do that? We just give it a modifier weight. So I'm just going to add the modifier weight here, and the same thing here. Now let's run it again, and yep, it's updated, but it doesn't look like the one that we have expected, right? Yep, that's because the surface modifier is giving the padding, but it's not including the background before it's giving the padding. So how do we fix it? We just make in our own implementation using modifiers. So just write in a modifier. So first we want its size to be 120 dp, so put the size to be 120 dp, then change the chain the clip modifier to give it a shape, and it's going to be a type of circle shape, and then give it a background of green 20 as we thought before, and now give it a padding of 48 dp. Now we should get most probably the UI that we wanted. Let's just check it out. That's the best thing about Compose. You need not always think that okay, it's going to work and have full confidence on your intuition. You can just click a button and it's going to show you. And yep, it's almost close to the UI that we expected it, but I feel it's a bit bigger, so I'm just going to reduce it to 100 dp. And if you observe, the padding was too much, so I'm just going to reduce it to 36 dp, and or maybe that's even too much, 32 dp. I guess 28 would suffice. Yep, that's perfect. Now as you can see, the icon is having a default background color of white, so let's just override that using the modifier dot background color green 20. And with that, let's just reformat our code, and I'm just going to hide this panel so that we get a bigger screen for the editor. Almost close to achieving the UI that we wanted, but I feel this text is still a bit bigger, so instead of giving it a weight of 1f, let's just change it and give it a manual width. So I'm just going to give it a width of 300 dp. Let's just test it. See, that's the thing I'm telling you. Compose is such powerful that it sometimes gives you the perfect thing that you want, sometimes it's not very good at giving you the thing that you want. So here 300 has also become too much. 200, let's just compare it with the UI. I think it's a bit much, and I guess 150 would be perfect. Yes, that's perfect right now. And now we want these to be having space in between them. For that we can just use the space between modifier, or the alignment of space between. So in the row, just given the horizontal arrangement, so it changes between the word arrangement and alignment. For row, the horizontal is an arrangement and vertical is an alignment. For the column, the vertical is the arrangement and the horizontal is alignment. So here it will be arrangement dot space between. And now let's run our code and refresh the UI, and yep, that's perfect. Now one more thing that we wanted was some gap or some space between this logo and the text out here. So you can just put that using a spacer, and I'm just going to give a custom spacing modifier dot height 48 dp, and oops, just put an extra modifier one, and we want, then we'll have some space here, so we're going to need to tell this to just stick to the bottom. So let's just do that here. The vertical alignment should be to the end, alignment dot bottom. And now let's just refresh it. As you can see, we are starting to get the feeling, the one of what we wanted. So yep, 48 is a bit much. Let's just change it to 32, and yep, that feels a bit better, but I think we can still improve it. Yep, 24, that's perfect. Now let's just make the text a bit bigger. How do you do that? Just give a style, or you could just give in a custom value for it, but we have started to use the material theme and material implementation, so let's go from there. So you can use the typography dot we'll go for display small. You can just head over to m3.material.io and learn more about typography from there. Okay, it still looks a bit big, so I'm just going to shift towards title. Okay, that looks a bit small. So it's about you trying to understand what's the best for your UI. So I guess I can go for headline medium. It's just a game of guess. Okay, it's a bit small, it's a bit big, but I think I can just fix it with headline small. Yep, that looks a lot better, but I guess we could fix it up. I could just increase the size of the overall row or the column, by the way, sorry, my mistake, but we can just reduce down the size of the image itself. So I'm just going to give it modifier dot width, and I'm just going to give it 150 dp as previous. And yep, this is surely looking like the UI we had been given with. Next, below all of this and the row, we had the text fields. So let's now denote them up. So just give the text field, but now the text field is taking in two parameters. One is the value parameter, the other one is the on value change parameter. So let's see how do we define both of them. If you can just hover over them, the value is of the type string, and the on value change is of the type a function that is going to be returning a string. So for present, I'm just going to give it a default value of say 123, and on value change, I'm just going to be a function. And let's just think about how do we go for the syntax. So if you see, the text field is a bit tricky concept, but let's just try to cover it in the most easiest way possible. A text field takes in two parameters. One is the value, one is the on value change. So what are they? The value is whatever is displayed on the screen of the text field, or whatever the user has inputted. But I guess you might feel it's so intuitive that when you have a variable, that you could pass in some variable, like say I could define another variable called name with a default text of empty, and I could use that as a value. So every time the text is going to type, it's going to update that value. But no, Android is not going to be doing that for you. I know it's a bit not so intuitive, but we just have to go along with it. So the value parameter is just going to display some text, whereas when the keyboard presses some key and there is some text input that has occurred, then the on value change function will be called and is going to give us back whatever the change was as a string. So that's why we have a string which is currently called it. So to start with it, I'm going to define a variable called name, because that is the first input which we're going to be taking from the user. Let's have it a default value of nothing. It's just going to be empty, because that's what we want. We don't want some default name already given to the user. So I'm just going to use that here as the variable thing that I want to use. And in the on value change function, I'm just going to set the name variable to the one that the system has given me. So every time I'm up to date with the value of the variable. So you might think, okay, I'm just going to run this project and it's going to work all great. But there's a small thing here. You have asked the operating system to give you some text that the user has changed by typing in some key, and you're assigning it to the variable name. Perfect. But did you observe one thing? You're using that same thing to display the text. So even if the user press the key, here your name variable has updated, but you haven't told Compose to update for it. So you always need to tell Compose to start reading for changes in that particular variable if it's going to change during runtime and you need some visual change to follow it. So how do you do that? You just wrap the string around inside a mutable state of. So what that's going to do, it's going to convert your it's the mutable state of. What is that going to do? It's going to take in the value or parameter, whatever you have given it. It could be it's not only strings, it could take any value, like it could take numbers or any other primitives that we have discussed before. But in our context, it was just a string. So it's going to take any default value, but wrap it in a state. State is something which Compose can read and understand. And if there is a change in state, it's going to redraw the screen. And as you can see here, Compose is telling us creating a state object during composition without using remember. That is because we haven't actually remembered the state. So how does Compose compare two states? Like say initially you had a empty string and then later you have something else. How does Compose understand that, okay, there is something that has changed? You need something to compare it with, right? You need the previous string to compare it with okay, there is some change now. So to tell Compose, okay, do remember the previous version and now remember the new version, so that you can just compare them, and whenever there's a difference, you just draw the screen again. So we just wrap it around a remember composable, and you're all good to go. So as you can see here now, text field gives an issue. You might guess why. When you wrap something under a mutable state type, the type is going to change from the primitive to the mutable state of the type primitive. But text field doesn't recognize mutable states. It's only recognizing primitives. How do you just fix that? Either you can use name.value and that's automatically going to fix it, or else you can just use the Kotlin keyword by to replace the equal to sign, and that's automatically going to put dot value everywhere you call name. Here you can just see it's causing an issue, and that's just because of the import. So just import it in and you should be all good to go. Yeah. So here now the text is field is now not giving us any issue because we have just converted the mutable state to the string, but still it's just housing the mutable state up. We haven't changed the primitive type. We are just gaining access to the primitive value from inside of the state. So the text field is going to take in a value which is going to be of the type name, and when its value changes, we're going to be updating that variable so that we can show it on the screen. So it's that easy creating a text field. And if you just run it, we should be having a text field on our screen. So let's just give Compose a minute to just draw it on the screen. Hooray, we got it. But I don't think you expected that result. You expected the name variable to pop up on the text field as a placeholder or a hint. But sorry, Compose doesn't give you that by hand. You have to manually do it. So just add in the placeholder composable, or you could also go for the label composable, and we're going to be going for the label composable here because it's a fill text field. If you're going for an outline text field, then you could prefer a hint composable function. So here the label is just going to have a text. You might have thought that label you could just give in a string and it's going to put that as a label, but sorry, Compose is everything about composables, right? So you just need to give in a text as the composable for the label, and that's just going to have the word name. So now let's refresh it and it should look as intended. Yep, as you can see here, our composable now has the option to input some name. Okay, wonderful. Now let's just add in up the remaining. I'm just going to copy and paste this code multiple times. Okay, now let's start updating the placeholder so that we get to know what are the correct order. So date of birth would be one of the text field, another text field would be email address, another text field would be the website, and another text field would be for projects, another text field would be for the number of awards, another text field would be for, I'm just going to paste it in. Oops. Another text field is for experience, another text field is for the bio. And now, as we did remember from the UI screen that we were shown, these three text fields should be side by side or one beside the other. So let's just wrap them around a row. And now let's just refresh the screen. But before we move on, we should just create the different variables for them as well, as just as we did for the name. So I'm just going to do them quick. So our date of birth by remember mutable state of, then that's also going to be an empty string. Let's just copy and paste it for time saving and start changing them. This is going to be for the email address, this one's going to be for the website URL, this one's going to be for projects completed, this is going to be for awards, and then another one is for experience, and another one, and the last one for the bio. Now let's just update our text fields to take their respective variables. So this is for date of birth, same thing here, and then this is for email address, this is for the website URL, let's update it here as well. Next, this is for projects completed, and this is projects completed. Next, here we are going to have awards, and here as well we're going to have awards, and here experience, experience, yep. And here the same thing, experience. And then finally here we're going to change the value to be bio, and on value change we should update the bio in this particular text field. And now let's run it. Okay. There seems to be some issue. Let's just check it out why. Here if we see, the row has actually caused the minimum width for the text field to take. So like the text field took the default value of width that it could take, but we don't want that. So let's just update it. We already know how to do, and we know that we want it to take how much ever it just requires. So let's just give it a modifier equals to modifier dot weight 1f, and that should fix it. Let's just add in the same modifier to all of them, and then run a project again. Now if you observe, here we have the text fields now in a row, but something doesn't look right? We do need spaces between each of them. So you could either give multiple spaces, but I guess that wouldn't be much effective. So what would you do? So simple, I'm just going to create arrangement, vertical arrangement for my column, and in arrangement I have a function called space by, and that's going to add a space for each and every composable in that particular column, and then we're just going to give it around 12 dp spacing for each. Now let's just refresh it, and we should expect the UI that we wanted to actually see. Yep. So now we have given some spacing. Let's just do the same for this row as well, but here it's going to be horizontal arrangement, and arrangements with space by, let's give it 24 dp of horizontal spacing. Now let's just refresh the UI. Okay, that looks good, but as you can see, due to 24 dp, like it was too much, such that it got expanded. I'm just going to change it to 12 dp, and yet it still causes an issue. How do we do it? We just change the font size, and we change it to 12.sp. dp is for composables and sizes, whereas sp is the same thing but for text. So now let's just update it, and yeah, now they're all in one line. Perfect. So we are almost close to the UI that we wanted. The only thing left is to add in our implementation for how would we want each of the text fields to show the keyboard. So the name would automatically show us the keyboard for some text, but we could tell Compose that, okay, hey, this is a text field for name. How do we do it? You could just go to keyboard options, and then that would take in a type of keyboard options. And then if you just observe the keyboard options, it has keyboard type. So just go for there and choose keyboard type dot text. With that, Compose will automatically understand that this is something that is going to be entering in some text. Next, let's do one for the DOB. There it would be keyboard options. Oops. Keyboard options, and then we want the keyboard type to be of the type. So because we don't have in a date keyboard type, let's just stick with the default for now. So let's just remove it here, but we hope that it soon be there in Compose. And then let's place it in here. Keyboard options, keyboard options, and then we're going to be taking a keyboard type of email address. And luckily we do have one for email, so let's just choose that up. And then here we'd be needing a type of website or URL. So let's just go to keyboard options and then same thing, keyboard type. So you might have already understood that Compose is natively best when experienced as a play. So we're going for the URI, and then projects, I guess the user would be entering a number. So let's just copy it in. It's not a type of URI, it's just a type of number. Now let's just copy this and paste it for all of them, for the awards, for the experience as well. And then bio would just be text. So I guess he can just choose what type of text does he want to enter. And now we can just click on the refresh. We won't get much update on the UI, but it will surely update when we just click on the keyboard. So that's done, and the final finishing touch will be just to add in the button. So let's add in the button, and as we saw, button is so easy to integrate. The button is already a composable, which is having a parameter of type on click, which is just a function that is to be run every time the button is clicked. So any code you'll write inside this on click functionality is going to be run when the button is pressed. The other one is just the composable, wherein you have a row scope and you can just put in all the things which you want to display once your button is composed. So here generally we'll be having in some text. Here the text would be create portfolio, and then we'll have some spacer to space them apart, and then just wait. So I forgot to put it a capital letter, and then 1F. Then we have the icon, and then it's going to just take an icons dot rounded dot arrow forward. Content description is next. So now let's just refresh it so that we get our updated UI. So to just create a button, you have to provide in a parameter on click that is containing the code that you want to run whenever the button is pressed. Then inside we just it's just accepting the different content that you would want to place on the button. For people who are migrating from views, this might seem a little bit awkward because previously in views you could just give in a string and that would be the text for the button. But here you can just provide in your own composables that are present in the row scope for the button content. Here if you see, we got a button, but it doesn't look matching with your UI. So let's just compose it using modifiers to match our theme. So we need to set its colors. So just use the colors parameter. You can just hover over any composable to see what all parameters does this accept. So here as we can see, the colors is of the type button colors. So you just go to button defaults. It might sound little bit not intuitive, but you can just go online to the Compose website and see what is the value that you need to provide for that particular parameter. Here if you see, we already have the button colors function in the button defaults class. You can just overwrite it to have the container color be orange, and that's it. Let's just refresh it, and now you should see an orange button instead of the default blue one. Yep. But now we wanted to have some padding, and also that the shape is a rounded rectangle. So just modify the shape to a rounded corner shape, and I prefer not giving it a size because I don't know what would it be. I always usually prefer a percentage, so I prefer a rounded corner of 25 for this button. Yep, it's starting to look. So now let's just give the text a modifier and padding. So modifier dot padding of 24 dp on all sides, and that should increase the height of the button. Yep, I guess 24 was a bit more. I'll just work with 12. Yeah, that looks good. But I felt I could just increase the size of the text. I'm just going to give it a style. Sorry for the typo. And then we just take the style from where? Material theme. Yes, material theme dot typography dot headline small. Just refresh it. And yep, I guess I could just go for a smaller one. Title image. Yeah, that looks much better. Yeah, I'm happy with that. Or I guess perfection is the key to life, right? So let's just be as perfect as we can. Yeah, that looks perfect. Yep. Let's just change it to 8. Now, usually we want this button to be at the bottommost of the screen. How do we do that? Just use the weight modifier. You must have already guessed by now. We have used the spacer a lot in this code lab. So just use the spacer, and when the modifier comes up, just use the weight parameter and just give it a 1f. And that would push the button to the bottom. Yep, as you can see, it's turning out pretty well now. And there's a small change that you could do to make it look a lot better. If you see, you could just add in some spacing here, and that could really make it a lot better. I'm just going to go ahead and do that. I'm just going to add in a modifier with a height of 8 dp. Yep. And one more thing which I'm going to do is I'm just here, if you see, the text field isn't taking the entire screen space, and that doesn't look unified along with the other composables. I'm just going to fix that around with the modifier. So modifier equals to modifier dot fill max width. I'm just going to be using the same thing around for them all. So just update them, and the row already has it, and finally here. Yeah. I'll just refresh it. Yeah, this looks a whole lot better, and it looks almost similar to our UI. So now we just need the background for our application. So let's just put in this whole column together inside of a surface, and then we should be good to go. So let's just call in a surface. Okay. The surface also should take in the entire size, and then have a color of material theme dot color scheme dot background. So let's just refresh our UI. Okay, I'm able to view the color. It might not be much visible to you because of the very light texture. So with this, we have finished in the information screen or KT. So let's add it up. So you just call in the information screen, and with that we are done. But did you think of something? Here we have defined all the inputs that the user would be giving us, that's name, the date of birth, the email address, the website URL, the project completed, and the awards and the experience in the bio. But what would happen when we clicked on the create portfolio button? It would go to another screen, and in the other screen we would need to access these variables, but they currently now stick to this screen. But how would you change that? So that's where state hoisting comes in Jetpack Compose. It's one of the most important concepts, and it's a very easy one. So what I first do, I just hoist these variables, like I change the position or the location of these variables to a place which is a bit higher in the navigation graph. So the information screen is called from where? It's called from the nav graph. So I just push all these variables from defining them in the information screen into the nav host or the nav graph of my application, so that I could use them from wherever in my application. With that, I've state hoisted all of them, and now I could just simply use it. So now in my information screen I don't have access to them, but I could just access them all using uh, taking them as parameters. So the name would be of the type string, the date of birth would be of the type string, the email address would be of the type string, and then the website URL would be of the type string, projects completed would be of the type string, awards would be of the type string, experience would be of the type string, and then the bio would also be a type of string. Perfect. But I guess we could have to do one more thing as well. We don't only want to take in the input, we could also want to change them as well. So I'm just going to copy them all, and we're going to need to add a few more parameters. So one of them would be on name changed, and that's going to be taking a string, and it's a type of the function, so it's defined in such a way. Next, let's do the same thing for this as well. On date of birth changed, this change, just put everything in present tense, and then it would have the same return type. I'm just going to copy it, paste it up. Okay, let's just do that maybe first for them all. Okay, and then let's update the names. On email address change, on website URL change, on projects completed change, on awards change, on experience change, on bio change. Let's just make it uniform. Now let's just update our places. So instead of on value change and setting our name variable here, let's just call in on name change. Here the same thing, on date of birth change, on email address change, on website change, and the same one for here, on projects completed change, on awards change, and then on experience change, and finally on bio change. Yep. So with that, we have hoisted all of the groups and the variables that we need to a higher level, that is in the Portfolio-o-Matic nav graph. But if you see now, we need to provide in some default values. So let's just do that. So for all of the strings, it would be just an empty value. Let's just do that. And oops, yeah, we come to the function, so we'll just give it a default function. Okay, let's just copy this and just paste that instead of the default string that we have been pasting till now. And yeah, that should fix our issue with the preview. And yep, our preview is still working. Now here let's just give in the values, name, date, of birth, email address, website URL, projects completed, awards, oops, like a capital, okay, project completed, awards, experience, bio, and then for on name change, on date of birth change, on email ID change, on website URL change, and then on projects change, on awards change, on experience change, on bio change. So now let's just update the methods to ask them to update the variable itself. So name equals to it, date of birth equals to it, email address equals to it, website URL equals to it, on project change, so let's just projects completed equals to it, awards equals to it, experience equals to it, and on just bio equals to it. With that, now we have state hosted all of the variables, and we can now access them from anywhere within any other composable. So the only composable left that we need to define is the portfolio composable. So I'm just going to call it portfolio root. So I'm just going to define constant val portfolio root equals to portfolio. But we should be able to navigate to the portfolio root once we click on the submit button inside of the information screen. So we need to add in one more parameter, that on data submitted, which is going to be a type of string whenever the button is clicked. So let's just assign this function to a button instead of, so for the on click we just give on data submitted, and that should basically have a default value of empty. Oops, it's not going to return a type of string, sorry for the typo. It's just going to return a type of unit because it's a function. So now back here we need to know that when we click on the button or on the data submitted function is called in, we ask the nav controller to navigate it to the portfolio root. So just we use the navigate function on nav controller and we navigate to portfolio root, and that should navigate us to the portfolio root. So now let's just quickly design the portfolio root screen. I guess let's give you as a challenge. We'll just take a few minutes back, try it out, and once you're done, I'll code it till now. If you didn't get it, then you can just follow along. Okay guys, hope that you were able to do it. It's a fair simple task. So I'm just going to show you how did I do it. So I've created the portfolio screen.kt file. I've defined it as a composable named portfolio screen. I've taken all the arguments or the parameters from the previous screen, that was the information screen, the name, the age. I just converted the age, I've converted the date of birth into the age for easier reference, and I've converted and I've taken the email address, the website URL, and I've just added a new parameter called is student just for the UI purposes. It's not mandatory. Then we have the projects completed as a string, the awards as a string, experience as a string, and the bio. So all that I've just composed it as a composable called portfolio screen. Inside of that we have a scaffold. You might have wondered what is a scaffold, as we did not cover it previously. A scaffold is just like a template given by Android to place different stuff. Like here, if you observe in the UI, we have a button here at the bottom which is always floating. So to have a floating action button, I'm just using the scaffold, and I'm also using the scaffold for the back button at the top bar. So scaffold already has the template for the placement of various composables like floating action button, top bar, the button, bottom bar, the navigation bar and stuff. So I'm just using that. So inside the scaffold, we have the perimeter floating action button, and I've just passed in a floating action button which has the overall overview, which is very similar to a normal button in Compose. Inside that, I've just used an icon with the share icon, then given the content description. Next, we also have the top bar parameter. Inside the top bar parameter, I'm just using the small top app bar. That's why I said Compose is so intuitive that you can just understand what the composable does just by using the name. And it's also recommended that you do the same when you're creating your own composables. So this is just taking in a parameter of navigation icon, and I've given it an icon of arrow back, which is for this. And the content description is back. The title, I did not want any title on the page, so I've just given it an empty composable. You can just submit or supply empty composables just by using empty curly braces. I've just set the color to transparent. I've just overridden the default value to make it streamline with our UI. And the container color for the entire scaffold, I've just given it the background which I've been doing till now. Then I've just given it a column inside, because if you observe, all of the composables are put one below the other. And I've just given it the padding which is given to us by scaffold, so that we do not bump into any sizing issues with the floating action bar around and the top app bar around. Just removes those height and widths and gives us the available space for the content. Next up, we have another column. You might wonder, like, why do I have multiple columns altogether? That is because I had to divide the columns based on how they were relating to each other. So this column is just housing these composables. So if you observe, I just given it a modifier and a padding of 24 dp, because I don't want the entire screen to have 24 dp. I just wanted the content to be having 24 dp, and they're vertically spaced with 18 dp. So if you observe, there is an 18 dp spacing here, 18 dp spacing here, and an 18 dp spacing here. Next up, we have another column, because I don't want each of these lines to have an 18 dp padding. I had to put all of them together using another column, and so I just put them. So inside of that, we have our first text, hi I'm, and I've just given it a styling and the color. Next, if you observe, this text and these two texts are one below the other, whereas they are together in a relation with this image in a row. So I just made a row, and I just made it sure that it's a fill max width. Then I've created a column. In the column, we have the first text, which is the name, and I've given it the styling. And then we have the row. You might guess why the row. If he's a student, then only these come up, or else it's just developer. So once that's done, then if it's a student, as I said, then we're going to be having these, which is beside the word developer. So we just put it in a row, and that's a column here. That is this column, which you can observe here. Next, I just gave equal spacing of 28 dp after the column, which is this 28 dp over here, and then we have the image. So the image, I've just given currently existing image, and the content description is the user's profile, and I've given it a modifier of size 64 dp, and I've just clipped it to a circle shape. Later on, we have another spacer of 8 dp before the bio, and then we have a text composable for housing all of the bio, which is provided, and I just styled it using body medium. Next up, we have the text as a URL, website URL, and I just styled it, which is over here, and they're just spaced because of the space by parameter of 18 dp. Next up, we have a row that is housing these three category cards, that is projects, awards, experience. I just created a new composable called category card, so that I need not write the same lines of code multiple times. So I just created two parameters, title and value. Value, I just given it the default, like the value which we received, like project completed is 8, and then the title would be project, so on and so forth. We'll just look at category card in a minute. Next up, we have the surface. I just styled the surface with orange color, So and made it to expand the whole width of the screen and given it a rounded corner of 16%. Inside of that we have a column, as you can observe, because we have two text things and they are one below the other. There I just added some padding of 12 dp, and the horizontal is center horizontal. The horizontal alignment is alignment dot center horizontal. Inside we have the text. One is you can contact me at, and I've just styled in the text. The other one is the email address which you have received as a parameter for this function, and that I've just styled it again. Next up we have the spacer that is allowing us to push remaining content to the bottom of the screen. And next, if you observe, we have the box. You might guess why do we have the box. That is because I have some content which I want to stack on top of each other. So inside of the box I have a row because I wanted to send this text to the right side of the screen, whereas remaining I just wanted to customly place them. So I just created a row with the spacer 1f to send it to the right. The others is just a text with the age parameter that I have received. I've just done the calculation in the nav graph itself. We'll go to there in a minute. So I just styled the text and made it look big. The remaining is just some padding at the bottom that I just wanted it, and at the right side. And another composable in the box is a row again, and that row is going to house our Android image and a column having these text fields. So the row is having a vertical alignment of bottom because I want the text to align to the baseline of the image. So I've just given it the image. It's a static image of the Android robot, and I've given it a modifier of 100 dp of width. Next we have the spacer so that I can space my content out. Here instead of giving it 1f and 1f, I've just modified it such that the text is in the center. If I just give it 1f and 1f, it's going to tilt towards somewhere the right, but with just some playing around I just found out the correct values to be 1f and 3f. So the remaining part was just adding a column which was centered horizontally in alignment, and I've just had two texts inside with the credit for the developer, and I've just styled in the text. So now if we look at the category card, I've put the category cards in a row scope, and you can just define your composables to either have a row scope, a box scope, or a column scope, just to make sure that you can access this modifier weight. I wanted my cards to have equal weight, and if I had to create them outside of the row, I had to create them as a row scope composable. So you can just create a row scope or a column scope composable just by adding the word with a dot before the name of the function itself. So here we're accepting in two parameters, the title and the value, both are strings. So I just created a surface for the card, and I've given it a color, and I just styled them using modifiers of weight 1f, which we already know, and I just given it a default height of 120 dp, and I've just given a shape of 16% rounded corner. Inside that we have a column with alignment of in the horizontal axis as center horizontally. The modifier I've just given it so that we have some padding and spacing around, which is 8 dp, this spacing which you can see here. Inside that we have the spacer so that I can just align my content inside, so that I have a spacing at the bottom, but I have most of the space at the top and bottom of the value text. So I've done the same weight modifier 1f, weight modifier 1f, and in between those we have the text housing the value, and I just styled it, and another text at the bottom with the title. And here you might just find this a bit weird, but I'm just going to explain it quickly. So in case the title length, like here if you observe the word experience, if you just gave it the same size as the other words, it's not going to fit on the screen, it's going to be too big. So to just fix that around and make a workaround, I've just asked Compose, say, okay, if the title length, if the number of characters in the string was greater than or equal to 10, follow this theming, or else follow this theming. So you can use if statements and comparison between variables to dynamically alter your UI. So that was just my category card, and I've just given it a preview with some sample text. So I've just added that as a composable in our nav graph route, just as the same thing we have done for the information route. and I just call in the portfolio screen with all by passing in all of the parameters that you have just collected. So this was just how I put all of them together into one screen, and now if you run the project, you should be able to see the app live and running. Let's now do it. Okay, so let's just click on the run button. We should be able to see our app display its output here. Okay, before we go in there, I'm just going to show you how did I change the date of birth into the age. So I just formatted the date of birth string as it was being typed in into the format dd, mm, and yyyy. So if the date of birth length was equal to 2, I just added in the slash, like that's after the date, and then 1 slash after the month. So that was how I just formatted the string. Once I had formatted the string, I just used some simple Kotlin and Java formatting tools to I just declared how I've declared the date format, and I've asked Kotlin to use that format to pass the string which we have just passed in, and we get a date instance. Once I've got a date instance, I just created a calendar instance and set the time of that calendar to the one that was passed in as the date of birth. Then I've just used the difference between the year and the year of the day of DOB. Once we had that, I just checked if it was before or after. If it was before, then I just subtracted 1 year, and then I just navigated to portfolio root, and that was a variable that I just passed in here. So if you see our UI is up and perfect, you can just start typing in the values, and you can observe all the different things, how did they blend in together to give you a professional application. So let me just run the values. 18 right, 2004. And it seems to have some issue. And then my website. Oops. Projects 8, awards 12, experience 9. Then we just say bio, hello there, and click on the portfolio, and here you have it, the UI that we have just designed. It could correctly tell that I was 17 years old, and then it has put everything together as expected. So I hope you have learned how to design a basic level application, and if you're really interested, you can just try out this app that I'm going to show you now. So you could just take it as a challenge. This application is called Yojana, and it's an intermediate level application with the subtitle Plan Your Future. This is a to-do notes planner application, denotes the approach towards declarative programming, unidirectional data flow, different use cases, and complexity levels of APIs to help you learn about Compose and Android. It has a medium complexity, varied UI, Material Design 3 theme and Material U dynamic color, resource loading, UI testing, integration with architecture components like navigation, live data, fragments, view model, and features are you could view your day at a glance, plan out your week and work on them with focus, take notes and set reminders. So here are some UI snippets of the application. You could just try it out, or if you want, you could just go and look at the sample code available on my GitHub page. You can just take a screenshot and try them out, or you could just go to my GitHub and you'll find the screenshots which are on the screen, and you could try it from there. All of the assets would be on my GitHub, so you can just take it from there and you could work your way through. Okay, hope you liked it. Thank you for joining us today and being such an attentive and lovely audience, despite it being a weekend. I hope you have learned how to develop an Android application using Kotlin and Jetpack Compose. I thank my team and everyone for giving me this opportunity, and it was great hosting you today. On this note, I'd like to conclude. I'm Malla, your host, signing off.